Okay. Welcome to the November TAS General Meeting for the HCAA, last one for the year. And just a reminder for housekeeping, we got the exits either side, bathrooms back here, male and females. And for everyone, just a reminder, behaviour, everyone gets a go, everyone listens, gives respect to all presenters, and a reminder to affiliates as well. Keep the discussions to a minimum while others are presenting, and you'll get time for questions and answers at the end of each section. And yeah, we'll have some fun. So kicking off, we've got topic one, we've got new flow coming in, non-invasive solutions for public and commercial facilities from James Hay, and then we'll go into top two, zone pressure reduction systems designs from Lawrence, and then ICC overview, current and future changes with the AS 3500 international standards impacting designers and engineers, and how the Tasmanian industry can be involved with these changes from Tom Roberts. And then followed up Master Plumbers President's presentation to close us out for the year with Anthony Ballick. So thank you all. I'd like to acknowledge and thank our affiliate members, and a reminder to designers and contractors to pass on our details. Make sure everyone's aware and know of these nights to get everyone involved, and these nights are also listed for CPD points, so make sure you're registered at the door for that. And affiliates get access to all state meetings as well. Acknowledge special thanks to corporate members, and welcome to industry authorities. Thanks to Tas Water, Tas Gas, Tas Fire, CBOS, TPSA members for industry engagement. We're looking forward to future presentations and what we can line up each year. You know that we're always reaching out, and they're passing on information as well. And also always Master Plumbers, and special thanks to Angela from the Master Plumbers, who's always helping out, getting everyone involved, looking for ways we can improve the industry. And it's a really big help. We've also got Natalie here from the Master Plumbers, and with her industry engagement. Natalie's, yeah, you'll see her at all the forums and helping out. So thanks again for everything and your support. Okay. And our members, of course. So the designers that are here today and online. And again, there's many other consultants that we need to make sure that they're aware of these nights so they can come along and get involved as well. So pass it on to everyone you speak to. My name's I'm Ryan Pekovic. I'm the TAS chapter manager. I've been with the association for many years now, and been thrown in. So hydraulic consultant down here as well, and you all know, reach out to me or Emily for any national or state questions. And no local new members, but there's these are some of the people from around the country that have recently renewed or joined for the first time. So that's a great shout out to all those guys. So NCC updates for 2025. NCC was published in February will be published, sorry, in February 26th. States and territories can consider the adoptions. NCC 25 is a matter for each jurisdiction. For example, our state has paused implementation of the NCC 2025 measures. For more information, you can find that on the Building Ministers meeting communique from October, and there's a link there as well. That means we're staying with the current standard, not 2025 until further notice. Recently, the Master Plumbers Association, ACT, and the Hydraulic Association had some awards in the and the Consultant of the Year. There was the President, Derek Harris, who you all met last in August. He was out there at the ACT Manager, Carl, and last week they had the awards, and the new Hydraulic Consultant of the Year was delegated and presented to Luke Hall from Slicks Consulting. So that's pretty cool. Oop. And next week, this Friday, sorry, South Australia is having their fifth year, 25 years anniversary of the association. So they've been going for a very long time, and they've got some celebrations coming up on Friday, and it's opened if you're going down. Taswater, some news updates. Taswater had 2 new documents they wanted to remind everyone. I'm not sure if it came out in any of the electronic news updates recently, but the 2 documents worth checking was the Taswater guidelines for Taswater developments and assessments, and little key bit there was its aim was providing guidance information for consultants, consumers, council and permit authorities regarding Taswater requirements and approach to development assessments. It had some guidance in there for documentation requirements, details that should be submitted to them for CCWs, and a bit of information on suitably qualified designers. Taswater, the second one that was out was the Taswater backflow containment selection requirements. That was back in September, or a bit earlier in the year, sorry. And Taswater is committed to protection of their water supplies, and it kind of links everyone back to the NCC Volume 3 for determining your hazard level requirements. So I just wanted to bring that to everyone's attention, that those new documents are out there on their webpage for you to get access to. So a little bit of pre-hot topics. We've got some different stuff going on. I'm going to say it again. On your desk, you've got the hot topics there for you guys to fill out if you can. That would be great. I can see everyone rushing with their pens. Natalie's also done a QR code for the people that don't want to do handwriting anymore. They want to use their phones. You can scan it and fill it out, and that will also come back to us. So it'd be really good if you can do that. That would be great. So you know the gist. Put down who you are, put down what you're seeing in common defects, common upsets, and list the topics that you want to see in the future. It helps us gain knowledge and see where you want information to go. These things go out to, we're going to collaborate all these and give them back to CBOS, TPSA, Master Plumbers that can also help future CPD days and training and everything else. So please, thanks for jumping at that. Little bit of fun. These were sent in from somewhere up north. I don't know if it's a combined system or just seeing what they can do on those downpipes. This one, some hydrant systems and coverage, and maybe fencing and finished surface levels can affect your actual design and compliance at the end of the job. Tassie made the plumbers crack. I don't know if anyone's following that, but I've seen this one. I took a photo. Don't know the job, but I can already know what happens. It's Hobart Heritage Building, Legacy Connections, trying to comply, probably not in scope, forced to do something to get it final sign off. Did this help or not? And that's in front of an architect's office. So I thought that was golden. Oh, look at that. I've already gone back to it. So again, everyone's jumping in there. filling out. No one wants to fill out anything in front of anyone. Not even a QR code scan. Fuck. Come on. Okay, what did we hear? What did we learn from August? You can see it there. Okay, 350 or 350 pits. Can we get them? Stormwater treatment, starting works without permits, incorrect use of forms, rainwater tank installations, contractors changing the install from design. So those were common defects that people called out from all different parts. They were comments from contractors, designers, inspectors, everyone. So common upsets on design. So now we're going the other way. Floor waste, vents, branch connections. Yeah, unstable ground. That's a good one. Create a standard for all items. That comment, I think there was a bit more to it about trying to want every hydraulic design to have standardised comments and labels and all that. So yeah, and changing performance solutions, then expecting consultants to sign off at the end of non-compliance install. Presentations. So we had requests for siphonic systems, compliance, unstable ground, stormwater detention systems, submissions. This one kind of goes on. So this one was kind of presentations, requests for about, yeah, what's low risk works, forms that you use, ASCONs, notifiable projects, you know, forms again, 71Bs, ASCONs, permit works, forms 46s, testing after commissioning. So that might be a CBOS presentation. We'll see where that goes. Yeah, it's good. See, feedback's good. Put it in. I saw one person. I think that was good. Inquiries again. Just to recap. HCAA administration. Emily's in the background. You met Emily last in August as well. Feedback, future topics, help. Reach out. You've got the emails, the contacts there. I've changed it up. There you go. Thank you. That was the committee section. I kind of pushed through that one. Ooh. I really took a lot out of that data. Probably just roll straight through to topic one, I reckon. So we're going to, everyone welcome New Flow and insights from James from Queensland.
Oh, right. I was going to take the microphone out and walk around a bit, so can't do that now. It's fine.
Oh, you can take the mic out. Oh, no, not for the next
yes, yeah, that's fine. G'day everyone. My name's James Holler. I'm with New Flow. Today I'll be talking about non-invasive solutions for public and commercial facilities. We have New Flow, both Jason and I, here on behalf of Hora Plumbing. They're one of our franchise partners. Just to give you a bit of a background on who we are, we're New Flow Australasia. We're a trenchless pipe rehabilitation franchise. We have over 50 partners across Australia, New Zealand, and Asia. All our partners are trained and accredited installers. Because us being a franchise, we make sure that all our partners are trained using our products. We have over 20 years in trenchless rehabilitation. Started out around 2004 using a US system and brought it over to the Australian market, and actually taken it and grown it and really invested and innovated. We partner also with one of the world's best global companies and technologies. So while we're a manufacturer on the Gold Coast, manufacturing our own products, so most of our products are Australian made. We have our own factory, manufacture our products as 9001 standard for the ISO. And we also blend our own resins. We also partner with technologies where we don't need to manufacture ourselves. We serve multiple industries: the infrastructure, facility management, residential strata, and industrial mining. So today, while I'm talking, we'll be going through what trenchless rehabilitation can do for commercial facilities, public spaces, how the non-invasive solutions are much more beneficial than traditional replacement. So we'll go through the common issues. First up, the industry reality, common failure points in buildings, and why pipes fail, before we move on to the different methods and solutions that we offer. So, aging pipework across commercial buildings, public facilities, hospitals, airports, education, industrial assets. As everyone knows, that a lot of the assets are coming to the end of their service life or their design life, so they're all failing, and a lot out there in Australia and New Zealand, especially, that we see failing areas at a time and going to do their preventative maintenance, go through and having these issues along the line. So having a trenchless solution will probably be beneficial, and having less disruption there. Many systems that are built, the materials are now, in their service life. Access constraints, rises, ceilings, basements and shafts. That's one of the biggest issues, is getting access to the piping systems. We find that you've only got access points where you can do pretty much your camera work. To go and actually fix the pipe, you have to start taking away walls, ceilings, digging up slabs. Replacement comes construction project, demolition shutdowns. The real cost sometimes isn't actually the pipe failure itself. Sometimes it is the disruption caused by accessing. Common failure points in buildings. Vertical sewer and stormwater stacks, especially when you've got your FRC sort of stacks there, and even your PVC and your GAL. There is issues that are caused, cracks involved, failed joints, trade waste lines exposed to chemicals, fat oil and gas, fat oil and grease, and thermal shock. Stormwater systems with joint movement and root intrusion. It's a lot of movement, especially in buildings and ground too. Stabilisation tends to cause failures in pipes. You got your copper potable lines with pinning, corrosion, and MIC. So a lot of issues there itself. Condensation, chilled water and drainage lines, also problems. Plant and drainage and service pipe work. Your fire systems as well. All the internal corrosion causing issues, blockages, especially your fire services is the problem. Typically, if it's when you need it most, it's not going to work for you because it's all rusted up. While these pipes fail, your long-term material degradation, building movement, settlement, high pressure or aggressive cleaning. When you've got your plumbers going in there and actually clean the pipes, especially your corroded pipes. While the pipes are corroding, you're obviously minimising your wall thickness in your pipe, and then you end up in more problems than you started out with. Chemical and thermal exposure as well. So especially the trade waste lines, that's another big problem, especially in buildings where the pipework itself isn't suited for your trade waste. Say a building's got a restaurant or a cafe or something going in, and the pipework isn't suited to the drainage that it's originally been used. There's also issues that arise from that, but there are solutions out there that can actually, without having to change the pipework itself, you can actually go through and repurpose it using a trenchless solution. Lack of accessible maintenance pathways and limited and consistent condition monitoring are also a couple of, and that comes down to the asset managers, whether or not that they actually have a budget for it at the time. Tend to leave things into the last minute until actually the problem arises. They don't do enough preventive maintenance. So out of this, you get your traditional replacement, right? Obviously, you go through opening your ceilings, your walls, your floors, your risers, digging up slabs. You've got noise, dust, and disruption to the building itself. Obviously, you don't want to disrupt the residents. You don't want to disrupt any services. Working with asbestos, silica dust, controls are required in many older facilities. Obviously, you've got to go through and take the right measures to go and remove that. Multiple trades are required for reinstatement as well, especially if you're working in across a road, if you're working in areas where there's multiple assets involved. shutdowns and after hours work too. So if you're working in a public space, you tend to want to do that work after hours. But if you've got the option to do it with a trenchless method, and you do it while people are actually still going about their business, I think that would be a benefit for everyone. Extended project timelines due to sequencing is also part of that traditional replacement. So a couple of non-invasive repair methods. What it is to reduce or avoid demolition. That's the main thing for your trenchless rehabilitation, is to prevent any sort of disruption, any sort of damage. You can even cause structural damage when you're trying to get to these things, especially if you're trying to break into columns, get into shafts, digging up slabs. There are also a lot of issues when you're external issues, apart from actually fixing the pipe itself. Another reason why you want to use a non-invasive repair method is it can be performed within live occupied buildings. So business can go about its day, services can continue, residents can still go and do what they normally do about their day, and you'll have your guys there putting in a relining material, going fixing the actual problem itself, and be out within the same day, and none the wiser. Everyone keeps out of the way, especially our reliners. We like to keep it clean when we get there when we see it the first time. Minimising downtime and reinstatement too, especially with businesses, or if you've got big facilities like your food processing facilities. Obviously, any sort of downtime is a big cost to them. So having some sort of repair method where they're not having to shut down. If we are to do it after hours, we can do that as also, but we're also doing it without interrupting any of their services. And as trenchless repair method or non-invasive, we're also providing options when access is restricted. So generally, the reason why I say that is that if there is really restricted access, we tend to make something work, whether it is like considering something like keyhole surgery, where we can make some sort of opening where it's only minimal just to get something into the pipe, whether it's taking a little square out of the wall to fix something that's 3 floors up. That happens. So just gonna grab some water. So for everything, when we're looking at trenchless repair method, we do our CCTV and diagnostics. So it's a good system to have there. So we can actually go through and put a camera into the pipe and actually look at what that problem is. Generally, when you're looking at a problem, especially in your buildings, and you've got a leak on the 3rd floor, if you've got a leak in the ground somewhere in the slab and it's popped up over there, it's probably not the space that it's in, and you're going to dig it up and you find out the leak's probably the water's tracked from 10 metres away or 5 metres away, or if it's underneath the retaining wall. Having that CCTV, we're able to go through, pull that the pipe camera in there, and as you can see, the different pipe cameras that are available. We've got push rod, pretty much a little camera that can get inside very minimal openings, go through the pipe and actually be able to see the full circumference of the pipe from a certain section, see where that leak is, see where any of those roots are coming in, see where the corrosion is, if it's 1 spot, 2 spots, and then actually be able to locate where that is using like a sonde, and actually be able to find exactly where it is. We also have crawlers, pan and tilt, high resolution systems for longer distance runs. So any pipes that are anywhere up to 200 metres in length will have a tractor camera that can go through and identify all the joins, make sure all the joins are actually to code. If there are any defects, make sure that everything's signed off. If we can see anything that is needing to be addressed, we can go through and put a patch. Also doing laser profiling, no validity, deformation measurement too. So you've got cameras out there that actually go through and do a laser scan of the whole pipe, make sure that there isn't actually any validity reduction in the pipe itself, and making sure it's deformation free. It's obviously there's tolerances there within the standard, but yeah, it's one of the other benefits of using these cameras. We can also, you can see there's a parachute inside. It does like a leak detection inside a live water main. It's a good little system. We partner with Saltire, and they use the pipper equipment, and we can do an audit on a water main up to 5 kilometres using a parachute and weightless line. So being able to find the issue within inside the pipe and having to actually try and find the leak externally when you've got other factors in play. External leak detection sometimes doesn't work. You can have things get in the way with the actual equipment, and you're not going to actually pinpoint what that is. With this system here, you can actually pinpoint it right down to the millimetre. We'll then go and clean and prepare the pipe using a couple of different methods. First up here, we've got the mechanical method. So pipes heavily corroded, and you do some descaling. If you've got fat build up, grease build up, I'll go through using chains and a milling equipment and go through and actually descale that whole pipe. Doing any sort of trenchless method is to make sure that that pipe is as good condition as it can be for that liner, or any sort of rehabilitation method to go inside the pipe. We want to make sure that there's no protrusions, make sure there's no roots. We want to make sure that there's no build up in the pipe. All those sort of factors there are going to come into play for your the effectiveness of the liner at the end of the rehabilitation. Lots of different other. That one there was done in Singapore with a job was there for a couple of weeks. You can see the amount of corrosion build up using pigs, mechanical pigs. Next one, which is very common, is your hydro cleaning, chemical clean, hydrojetting, effective for cleaning obviously blockages and any deposits, getting rid of any deposits. Any backflow over pressurization risks must be managed. Pressure selection depends on the pipe material and conditions. So if we're looking at the pipe, and again, like I was saying before, if that pipe is looking like it's going to fall apart from your actual cleaning of the pipe, you would have to use a lower volume or lower pressure. But there are lots of different jetting heads involved, different sizes too. So if you're working with pipe networks, you've got a couple of bends you need to try and get around. And then you've got a jetting head like that one there, you can see, where it can get around those bends as well. Bigger ones for bigger diameters. You've got root cutters. You've got spade bits where it's just taking the invert and pulling the length back behind you. Very high pressure, very effective. Chemical cleaning too. So there are actual solutions out there where you've got a build-up of grease. Trying to clean it with a jetter, good luck. You need heat at least to clean it out. But there's also other solutions out there where you can put, there's a product out there called Grease Grenade, which you can actually put into your jetter tank, and it's like an emulsifier, which actually emulsifies the grease at the same time. So you're actually pulling it all out. It works without having to have that heat along with it. So one of the rehabilitation methods is your localized structural repair. So pretty much it's a patching system. You go through and hold up. Let's go on to the next one. Yeah, you've got your different patches. It could be anywhere from your minimum for your AS 3500 standard is 400 mil. The reason for that is because you want to be making sure that you are not working from that you're at least 400 mil away from the any defect. If it's a defected join, if it's a circumferential crack, you want to make sure that you're at least 400 mil away, because the weakest point of that liner or that localized patch is the end of your liner. If you've got root intrusion, you're covering that, you want to be at least 400 mil away. Otherwise, those roots are going to continue to try and pressure and push through and then grow into the end of your liner. So that's why we make sure we stick to that minimum. Otherwise, for something that we look at for a defective join, where it's a crack or a join where we're a meter patch, so you're at least 500 mil either side, well above what the minimum requirement is, and you're getting something that's going to last your 50-year design life. Full length structural rehabilitation as well. So you've got your localized patch systems, and then you've also got your full length repair system. So that's more of your end-to-end sort of stuff. You can do anywhere from there are methods out there up to 200 meters in length. If you've got a pipe system that's much longer than that, you can do them in patches at a time. So there's systems out there where you can do, if you've got a 30-meter pipe, you can do it in two 15-meter length liners. You've got what they call an overlap, and that overlap is pretty much you can almost call it a seamless join. It's hardly noticeable. It will be positive lap to the flow, and then you'll have seamless join. And when you go through your camera, you won't even notice it. You'll have to pretty much know where the location is to find it. There's UV systems out there as well that do UV curing. So I'll be going through that in a moment. With these systems too, you can go through and do bends, multiple bends. We reline junctions as well. We reline transitions. You can see on the tables here, we've taken up the whole spot. But there's a couple of samples there. You can see a transition there. That one's a 150 by 100. You can see a 45 bend, but we can do 90 degree, and we can do all sorts of sizes as well. Those are your what we call a CIPP, which is your cure in place pipe. So out of these cure in place pipes, method one is your pull in place. So your pull in place liner, you can see that there on the table. Right, that. Right, so that's for your 1 meter patch. That liner there will be cured and look like that blue line, that pipe there, after it's done. So what it is, it's a tube made out of felt, could be made out of fiberglass. It gets it impregnated with an epoxy resin, right? And after that, we go and roll it up, pull it into the pipe, as you can see there on the video, and inflate it with a bladder. Bladder is made out of rubber, right? You got your rubber, you got your sleeves, got poly, got your end caps. Gets inflated with air, can get inflated with water, hot water, to speed up the curing process. But generally, that will get inflated inside the pipe and left to cure. Could be anywhere from an hour to 6 hours to 8 hours, depending on the resin that's used, the ambient temperature, and the diameter of the pipe and the length. I hope everyone's following. These, like I said, bends, junctions, transitions, traps. It is a very versatile system. You pull in place. You can do anywhere from 40 mil up to 1800 mil. You can do anywhere from a meter patch up to 50, 100 meters, 200 meters. It's a very versatile system. So that's your pull in place. The next method is your inversion. So it's a bit different. What it is a liner that actually gets inverted inside the pipe, which it should play. There we go. You probably would have seen it. It gets inverted inside the pipe, comes out the end, and then left to cure. We cured with air, could be cured with steam, but it is a system that requires you to have the access point also relined up to where you are needing to have your original patch. So let's say you're doing a pipe, you're fixing a pipe 10 meters down the line. You need to make sure that your liner is from that 0 meter mark to that 10 meter mark. You're going to have to line with that to actually get that fixed. Whereas the pull in place, you can actually pull it into position and inflate it. But then for the inversion too, is that you can invert 100 meters at a time, and you can steam cure it and cure it in an accelerated time. It could be cured within an hour or 2 hours. These both systems do bond to the hose pipe. So one of those things when you're looking at trenchless method is very important that you do bond to the pipe in most cases, because over time you're going to have movement of the pipe, you're going to have expansion and contraction, especially if you work with pressure. You are not going to want that to let go. We've had liners in the ground for years. We've been it for over 20 years, and we give a warranty for a reason up to 50 years. So there was never really a time that we actually have a liner missing, so, or a callback. Same thing, 40 to 1800 mil. UV curing, so this one here, similar to your pull-in-place, end-to-end. It is only end-to-end because what it needs is both access points to be open. We pull that liner into place. That liner, you can see that yellow coating on the outside. We've got a sample there too. That prevents any UV light actually getting into the liner and curing. What will happen, we pull that liner into place, inflate it. That liner will then have a light train, is what you can see there, get pulled through the pipe. That light train emits a certain wavelength, 395 nanometers. That wavelength and a certain wattage is going to cure the pipe up to 1.5 meters a minute at that calibrated speed. So any sort of long distance runs, larger bore, UV is the way to go. It just means that you're able to go through less disruption to your actual, if you're working with traffic control, working underneath the road, you want to make sure that you're done within a day's worth of work. We have a unit that does 150 up to 1200 mil and up to 200 meters in one installation, and that can be done in one day. Most of the time, you're looking at the cleaning and the preparation of the pipe first. That's going to be the bulk of your work. The lining is the easy part. A lot of these liners that you see here are considered either a semi-structural or full structural solution, which I'll go through shortly. And there's certain standards that it abides to for their 50-year design life. So just going through the process before, we prepare the liner, go through and impregnate the liner on site. This is for using the CIPB, just giving you a general idea of what that process looks like. We'll go through, start taping up the liner, taping a liner on the bladder, and then we'll go to that access point and inflate the liner inside the pipe once it's pulled in place. So yeah, we're inserting that liner. So this one here you can see it's at a hotel, gets inserted. So benefit of this is that we're actually using existing points, existing access points. We're not having to make our own, and we pull that liner into place, and then yeah, make sure that we're in position using cameras, using any sort of measuring tools. It could be putting some tape measure marks on the rope, or using our camera to line it up. This one here is a 750 mil stormwater pipe. You can see how it opens and actually conforms to the pipe. And you'll see resin migration start happening around those edges there. That resin migration is important, especially when you're trying to bond onto the pipe. You want that resin to migrate through any sort of crack, any sort of pitting, and actually really bond to the pipe. Now, if you're working with HDPE or any sort of pressure, you want to make sure that that pipe is prepared first. So we'll go through and sand it, give it a bit of a rough surface for that epoxy to bond to as well. Once it's in place and inflated, then we'll cure it. Generally, we'll cure it with ambient air, and then, like I said, depending on the temperature, it could be a certain amount of hours, but then we can accelerate curing using steam curing, trucks, boiler units, UV, or we can use hot water, and that's going to bring that cure down tenfold. Once that line is cured, we'll go down with the camera, deflate the bladder, pull that liner, that bladder out, and you're left with a fully cured pipe inside the old pipe. You can see we've lined it up to a junction there. It is a strong solution too, especially when you're working with PVC. It's stronger than the actual PVC itself. See, working with concrete's a bit different, but yeah, I'll come to that section about how we design the liners to suit. Considerations with CIPP is to make sure that the hose pipe must retain enough shape for the installation. So when we're looking at the pipe itself, if it's obviously really squashed, we can't get through there, we're not going to put a liner through it, it's not going to fix your problem. We can, if there is a section there that is squashed and it's not too long, go through there and bore it out, create a nice little opening there, and then pull the liner in place and inflate it and fix it. If you've got dislodgement, we're going to make sure that the displaced pipe isn't too displaced. If we can't get actual camera through there, if we can't pull the liner through, if we can't get a light train through, we're not going to try and fix it as it is. So we'll go through and try and cut out the invert of the dislodgement first, create a nice track, and then pull that liner into place. Access points are required for insertion and curing. So we generally work off 2 access points as a minimum. If we're working with 1 access point, it's not a problem. It just depends on what we're doing. If it's a patch, we can push it in place. If it is a multi-meter run, then we'll have to try and look for another access point to pull from using a longer distance rope. Liner design and material selection must be project specific. So especially when you're working with your stuff that requires a full structural liner, we go through and do calculations based on the AS/NZS 2566.1 standard and the ASTM F1216 to make sure that liner thickness is designed to suit all loads. And it's not suitable for completely collapsed light pipes, obviously. Don't really need to explain about that. Another solution was your internal coating. So it's not just a liner solution, you've got barrier systems as well. So these are generally used to extend the service life of your pipe. It is either a semi-structural or non-structural solution. Semi-structural would be based on how many coats you do put on the pipe and the pipe diameter itself. What it does is, obviously inhibits any further corrosion in the pipe, interpolation or minor leaks. Used on potable, HVAC and mechanical lines where certified, where it is certified such use. Used when repiping and requiring major demolition. So if you were to break down a wall just to get to the pipe and fix it, you can just use especially when you're working in stacked lines and you've got multiple connections, you don't necessarily need to use a liner. If it is just minor corrosion that you're trying to fix, you can go through and do some brush coating. And yeah, increase the internal surface condition and flow characteristics as well. Being a coat, you're not really worried about a reduction in ball size, so it's a benefit for all. The boundaries, obviously, it's not a full structural solution. The host pipe must be stable. Suitability depends on diameter access and material compatibility. Certification for audible applications is product specific, so you've got to make sure you've got that 40/20 approval, and it's not appropriate for significant structural defects. Being a coating, it's only just a resin. There's no other substrate there to actually reinforce it. Yeah, so one of the methods is your brush coating. So what it is, it's just a brush head that sits inside the pipe. You have a resin that sits behind that brush coating itself, pulls back and coats the entire surface of the pipe using that brush. You can do that multiple times. It can be sectional, it can be end to end, you can go around multiple bends, you can do T's. You can be applied in 2 to 4 coats depending on what the defect is. You can see there's a crack along the top of the pipe, and depending on how many coats you put on there, you could actually fully seal that crack. It is, like I said, non-structural, but it can be semi-structural. And you can go down from 32 mil up to 150 mil, generally with brush coating. Spray coating, similar, but you're using a centrifugal force. You're actually using a head that spins and throws the resin out to the internal surface of the pipe. This one here is another either semi-structural or non-structural solution that can be done mainly end to end. The reason why you'd use this as well is you can use it to repurpose the pipe. There was a job we did for Port Taranaki in New Zealand. It was 80 metres or 250 mil. It was a pipe that was for oil that was used to carry oil from the ship to the port. They wanted to repurpose that pipe. They were upgrading their firefighting towers to have that firefighting foam, and they wanted to repurpose the pipe for that foam to be carried to the towers. So went through and cleaned it and then used that solution to coat the pipes. And then the other solution here is blown. So it isn't spray, it is a system where you're actually blowing the epoxy from all your fixtures and out through one exhaust. It was originally designed for coating naval ships, the pipes inside naval ships, where they didn't want to be taking these pipes out. These pipes were having saltwater corrosion inside the pipe itself, or there have been instances where the wrong pipe had been installed, and then they needed to recoat it to get that potable approval. Otherwise, I think the issue was lead poisoning was the alternative, which no one wanted that. Go through, clean the pipe using a grit. It could be a sand, a silica carbide, it could be glass. That will clean the pipe, right? So that pipe will have built up a corrosion. You'll have multiple areas that need to be cleaned, multiple bends, it needs to go from one end to the other. So we're shooting grit through, like it's pretty much sandblasting inside the pipe, but it's shooting from one end to the other. That will take out all your debris, all your corrosion, and they'll create like a nice toothing profile inside the internal surface, allowing that epoxy to bond to the pipe. Got some samples there too. That's what we call our red line, and you can see, yeah, it's got your 12 mil half-inch samples and a couple of bigger ones there as well. It is potable water approved as well. So we do apartment buildings, all sorts. So yeah, key takeaways, non-invasive options do provide alternatives when replacing. It is highly disruptive. It is structural and non-structural technologies. Each have their roles. Suitability depends on condition, access, and engineering assessment. Early diagnostics reduce failures and unplanned downtime, and designing for maintainability actually helps proof assets. Here's some of the standards and specifications that we work under with a lot of the liners that are involved. This is something that is happening globally. Australia has their own standards, but Australia and New Zealand. When we are looking at a pipe that is needing a full structural solution, we have something, we need to specify what sort of liner thickness. So, like I said, we work at the AS-NZS 2566.1 standard for your full structural solution. That's your class 4. And then we work on the ASTM F1216 for your partial deterioration, which is the ability for the line to withstand groundwater pressure only. Non-structural is a class 2, corrosion protection, extension of service life, sealing. Class 3, semi-structural, partial deterioration, hose pipe. That hose pipe needs to be intact. All right, so that's where you're looking at your faulty joints. You're looking at minor cracks, and your even a dislodgement can be considered a partial deterioration because the pipe itself is still in good condition. We're just bridging a small gap. The CIPP support groundwater pressure, that's the ASTM F1216. Class 4, full structural, full deteriorated hose pipe. The CIPP needs to support hydraulic, soil, and live loads. Right, that's AS-NZS 2566.1, that flexible buried pipeline, and it's actually under a trenchless method. What we're looking at there is the pipe is to withstand all loads. So we need not to rely on the actual hose pipe itself. What we're looking at is the diameter of the pipe, the depth to invert or depth to depth of cover, what sort of soil modulus, what sort of, if there is any water table above the pipe, what are the live loads? Are we looking at road? Are we looking at rail? How close is it to the surface of that road? The closer to the surface of the road, the more external loading that it needs to withstand. All those factors come into play and will give us a certain thickness of liner that needs to be designed for that pipe as a 50-year design or a 100-year design. The other factor being the materials flexible modulus, that 3-minute bending modulus, or your 50-year, your 10,000 hour testing that was done, extrapolates that information to get you your 50-year design life, 20,000 hours for your 100-year. If there is pressure involved, we have pressure solutions as well, which allow us to, if we're looking at fire service pipes, if we're looking at potable water, water mains, rising mains, anything with pressure in it, we also look at that as part of the factor, and then you've got your combined loading, which come into play as well. 50-year design life, yet the materials engineered for the service or the equivalent of the new installation, improved hydraulic flow. So a lot of questions I get asked is, how does the liner improve the flow of the pipe when you're reducing the bore? And the answer I usually give them is that if you're looking at a pipe that's got heavy corrosion, if you've got cement lining failing, if you've got long-term degradation, you're going to have any sort of improvement with the flow with putting a liner in there, especially if you've got a liner that's glass. You're improving the coefficient, even with a reduced bore. The liner is only going to be anywhere from 3 mil thick, 10 mil thick, 12 mil thick, depending on the diameter. Obviously, is a big factor when we're looking at the thickness. But 9 times out of 10, based on what its current issue, current state, you've improved the flow based on calculations, and has been done and looked at. And that's, yeah, like I said, a question that's asked a lot. Just for example, a couple of case studies, high-rise, persistent leak in the 6th floor apartment was traced back to a cracked 100 mil PVC stormwater pipe embedded within a structural column of an 8-story building. Traditional pipe replacement was not feasible, and it would have compromised the building's structural integrity, necessitating a less invasive and more cost-effective solution. UFO's blue line pipe relining technology was chosen to create a new durable pipe inside the existing damaged one, eliminating any need for demolition or excavation. Number 2, hotel, having constant blockages and issues with their drainage. CCTV inspection found that the drains cast iron with substantial corrosion. Solids were catching on these points, resulting in constant blockages. Solution being a blue line, giving that brand new pipe within the old post pipe, bringing back that structural integrity also. Fire service need for repair, a network need for repair, large shopping centre. For transparency, this was Cairns Shopping Centre. All their fire service lines were heavily corroded. They were getting leaks popping up here, there and everywhere. We were working with the contractor Lend-Lease. Was failing their hydraulic pressure tests. Sludge and corrosion was found inside the pipe, and then the repair pipe relining with UFO's red line coating, that's that blowable epoxy. These pipe repair methods from UFO were being recognised as a superior technology for water pipe lining with commercial property maintenance. So since completing the repair, other major shopping centres have also inquired about our solutions. Just going to go through these. I've been told not to sell as the brand itself, but yeah. If there's any questions, feel free to come see me later and ask a bit more about our solutions. Yeah, thank you for your time. It's a different resin. So you've got a blue line, which is for your sanitary sewer, so your usual pH levels within that sewer system. If you're looking at a trade waste line, you're looking at something that needs to withstand up to 140 degrees Celsius, pH levels from 1 to 11, needs to handle all sorts of aggressive chemicals and alkalines. So our solution, HCAA, is a line, or out in the market, you've got a solution or a resin that's either high temp or acid resistant. And we have our own R&D department and polymer chemist on board, and we've designed a resin that suits both. So it needs to be heat cured for it to withstand that temperature. So if you want to withstand 140 degrees, you need to cure up around 140 degrees just to increase that transition blast index with the epoxy. But yeah, can do your trade waste lines in aggressive environments. Yes.
Sorry if I missed it. Those options you had for pressure line,
yes, so we have 40/20 approved resins. We've got a solution called Pressure Line that can do your fire service lines with our blue line, and then potable water networks for our water, our green line. So there's also another solution called ASO pipe and liner, which is like a pipe that gets dragged in. It's like slip lining almost. It's like Primus line, if anyone's ever heard of it, but it is a product that actually has 0 annular spacing suited to the internal diameter. But yes, we do have 40/20 approved products, and that's that red line as well. Any other questions?
In a couple of videos that showed you inserting through pipes that still have water running through.
Yep.
Do you get full adhesion? The pipes still better. Do you need?
So we have our center blue line, and we also have underwater curing blue line resins. So it's a resin that's specially formulated to actually create 0 washout resin. So we generally work with medium to low to medium flows in the pipe. We like to plug the pipe usually before we put the liner in, inflate it. We'll have flow through bladders that allow and continuous flow through the actual the cure at the same time, so we're not disrupting any sort of flow. But we have worked with flows in the pipe and pipes where it's been completely bogged with water, because what's happening is the compression itself is pushing that water out each end, and the resin itself will cure underneath water. Obviously, it take a bit longer, but that once that full compression happens, that resin is not touching any more water and it's going into those cracks and bonding to the actual hose pipe itself. Yes. Expansion of the pipe under heat. Yes. Yeah. Yep. We especially when we're working with a pressure pipe, right? That's one of those things that you need to consider is the expansion and contraction of pressure, especially when you're working with those pressures fluctuating. If you're working with pipes that are above ground, you're standing underneath a bridge and you've got heat from obviously the sun, and the middle pipe's expanding and contracting, we've got to take that into consideration too. So generally, when we're working with pressure, anything like that, we will go an end-to-end solution, and we'll actually flange those ends and seal them so that if there is any sort of expansion contraction, we're going to be completely independent. So we won't actually bond to the pipe, we won't need to, because we're actually sealing both of those ends.
The blue liner, are they required to do that pipes for
Yeah, so obviously all our trained operators, it depends on who you're working for, and usually you are compliant. When we're working inside the boundary, we've got to work with watermark approved products. So like our blue line and red line are watermark approved. So that's when you're working inside the boundary. We work to those other standards like your NZS 256.1 standard. So for councils particularly. So if the client themselves require any sort of that documentation, then that's given to you prior to the job. Yeah, and then they go through and do IQ reports as well. So our guys have like an IQ system which they go through, they scan in their products. They scan in the product used, the resin used. They have a GPS location of where that job was. All that information, how long it was cured for, what the diameter was, why it was actually aligned in the first place. We have a warranty for our products, a product warranty of up to 50 years for our blue line, UVs up to 25 years, Sumo line, which is our structural solutions, is a 30-year, and we back that warranty. So we're going to make sure that everything's done right. That's why we train our guys. So all that documentation is used, and plus the warranty given to the client after the job. Depends on who the client is. Is that you guys probably answer that question more so than I? Over here anyway.
If it's public.
Yeah. Yeah. If it's private within a household, like residential stuff, no. But if you're doing something for a obviously the council, tier 1 contractor, you're working for them anyway, so they're going to have that information. Anything other than that, yeah. If it's a private job, then no. Any other questions?
That example of the fire main.
Yep.
So if you've got a sluice valve or valve at one end,
Yep.
is it the brush repair so you can close the valve and just have access from one end and work all the way to that closed valve? Or
Yes.
You need access.
No, if you can push the solution to it, you can go for it. But yeah, any sort of valve, so if we can get access to it, we'll remove it. Yeah, if you're using the red line solution, you've got to take away any sort of valves. They're going to be your points of where we shoot the resin from. If you're doing any sort of work inside even drainage, where there might be a valve, in a dam, let's say, we will tend to ask the client if we can get access to that, remove the valve and use as one of our access points. Otherwise, we are lining up to it, and if we can get to it, and then we're left open with if there's a fair bit of head pressure, then we're risking any sort of delamination on that very start point. So if we can move the valve, if the valve's holding a whole lake behind you, then no, we're not going to take it apart. But yeah, it's one of those things. We try and look at every solution as per project and make sure that we are getting it right before we put the liner in the ground. Cool. Anything else? Thank you.
Thanks, James. And we've got the lucky privilege of having Matt Lloyd do trivia tonight. Getting to come up and mix it up a little bit. I hope everyone was listening.
Yeah. Hi everyone, my name's Matt Lloyd. We've tried this around the country a bit. It's been a bit of fun. What does work well is if everyone's got a question sheet, would be handy. I don't know if the back you would. We kind of had a bit of a printing issue. Have you guys got one up the back there, a sheet with a pen? If you don't, I might just do a reshuffle of a table. If I get you two there, and we can send one towards the back. But do you guys have one down there? Yeah, you got one? Everyone in the back row? Yep. Don't need any more sheets. Just to let you know how this kind of works. Everyone's got one. Obviously, no phone use during these questions. If you go to the toilet, please take someone from another table, just so that they can monitor your phone use while you're in there. There's 3 rounds with 3 questions. So 3 rounds, 3 questions. Someone on the table should be a scribe or your best speller. So think about that for the next couple of minutes. Who's the best speller on your table? There's lots and lots of great prizes here. So you are playing for something pretty hectic. So, put your thinking caps on. Shouldn't have to say this, but if you do know the answer, maybe don't yell it out because you're fairly close to the other tables. So can be. And I will just get whoever's got the pen in their hand, just think about the name of your team. Some names we've had in the past are the Sprinkler Heads, the Standards, the Kinko Nuts, the Electric Eels, the Multi Grips, the Plum Quicks, and the Mega Jewels. So feel free to choose any of those names. They're all industry related. But I will get on with this. So they're fairly quick rounds. This is round 1, question 1. In a straight line, or as far as the crow flies, I want you to think about the distance from Hobart to Alice Springs and the distance from Hobart to Brisbane. And which one of those would be the further distance? Yeah, straight line, as in a crow flying there, like a straight line. So, okay, so that's question 1. Which is the furthest distance, Brisbane or Alice Springs from Hobart? I'll give you a minute. So we normally spend a couple of minutes on these. I'll leave you alone. You might want to write something next to it and come back to it. But the idea is that the tables do discuss amongst each other. Hopefully, if you don't know someone on your table, you will know them by the end of the night. Question 2. The Bogues Brewery was opened in which year? 1881, 1891 or 1905? Okay, so question 2. The Bogues Brewery was opened in which year? 1881, 1891 or 1905? And question number 3, so this is question number 3, round 1. Of these countries, which one has the biggest foreign ownership of Australian water entitlements? China, Canada, USA, or the UK? Okay, so of these countries, which one has the biggest foreign ownership of Australia's water entitlements? That's China, Canada, USA, or the UK? Yep, we don't own everything here. Okay, so just whipping back through that, we've got the distance to either Brisbane or Alice Springs. We've got the Bogues Brewery question, and we've got the Australian water entitlements, and they were China, Canada, USA, or the UK. So that's round one. Good luck.
Just mention what's going on. All that you want to share.
Guys, so I just wanted to do a quick introduction to, firstly, Martin Bullock is here tonight. Martin has an Instagram account called Tassie Plumber Gas Fitter. And a couple of years ago, we filmed him for about 10 days around Tasmania doing plumbing work, really showcasing how good a career in plumbing would be. It's not just a good job, it's a great career. And it's also a great showcase from the plumbing industry in Tasmania on the world stage. So I just wanted to, in the breaks, play a bit of his episode. We've got we call it American Plumber Stories, but we'll change the name later. And just really showcase a bit of Martin's career journey and a little bit of plumbing work and where he, what he does around the state. So we'll just play that in the background in between the breaks and I can come back to it. But if you've got any questions about the show, Martin's here tonight to come and answer them. Anything you need. So, thank you.
He's the crocodile Dundee of the plumbing industry. So we look at heading off the way to the other side of the world to make money. I'm Greg Morgan. This is America's Plumber.
So these actual council presentations to the public.
I'm an Australian plumber, and I feel pretty privileged to show off Australian plumbing to the rest of the world.
Eric's plumber, I guess, would be the same, roughly the same as an Australian plumber, just different standards, I suppose.
My role at the International Code Council looks after all the plumbing, mechanical, and fuel gas solutions. Everywhere outside the USA, around the world, there's a lot of countries that don't have that same access and the same level of clean drinking water, proper sanitation, and it really separates those countries in what they have access to and how they can thrive as a society, as a country.
We do things differently down here in Oz, but one thing that sticks with me all the time is helping people. And we do stuff to help people and to better the industry.
Australia, we're quite fortunate. We've got a lot of access to clean drinking water, quite good sanitation conditions, and plumbers are the backbone to achieving that, keeping the country going.
About 8 years ago, I started up an Instagram account called Tasmania Public Gas Here. Part of my page is to showcase these places we go and the lifestyle of being a remote plumbing specialist. The one aspect that comes to remote plumbing is the travel. Sometimes we've got to drive hours to get to site, hiking, or catch a helicopter or a plane to the site.
I do worry about helicopters crashing.
So being a remote plumber has its perks, but there's also the hidden dangers.
But whatever you do in life, you have to have a passion. Well, Mark's passion is definitely plumbing.
Martin was always interested in how things worked, building things. It's always outside. Even when he read, he only read factual books about how to do things.
So growing up, I was quite hands-on. I liked to be outside, do adventurous sort of stuff. We didn't have finance back then, so you still had to make your own fun.
We would always pack up the car on Friday and boot the shed that evening and tear up the lakes.
He used to build dams and run water into it.
We didn't really sit around and watch TV, and when you experience that, it really shapes your adult life.
I remember this day. We were up at our shack at London Lakes and Martin went fly fishing with his father. And this, I think, was the biggest trout that Martin ever caught on the fly, and he was very proud of it.
There's some good times we had up in the Highlands of Tasmania.
It's not every time you see right here, it's being I did them more than like, I know much, and we did large work, we did very well. That's what's going on in the beach, that's one more out, it's going to be.
What you earn air miles on your everyday spending? And that's true. It's close for anything.
I was always a plumber. I tried at the post office and I realised straight away we might be stuck inside doing that.
I've been stuck in the shed. I noticed he was always working outside and doing different things, and that's something that really appealed to me at the time.
Over the years, I built several shacks up in Lake, of course. Did a lot of plumbing up there too, so Martin would have first-hand experience with that.
I went and did some work experience with my father.
He came along and wanted to do an impression as a plumber, so.
Then I really enjoyed it and wrote some history. So today we're going to Cape Barren Island. It is a remote island off the shore of the northeast of Tasmania. It's a Aboriginal community, approximately 80 people. If anything that's been fixed or installed, they have to send people over from mainland Tasmania. To get there, we travel a couple of hours by car, and then we fly over a small plane. I have to get all the gear ready. Some of the big stuff we're actually going to ship over in the ferry because we're going to take in the plane. It's very important that we don't forget anything. Because you can't just go down the road, get something. So it's got to be very thorough. When we first got to know the pilots quite well, and a little bit stressed about the amount of gear that we take in the plane. It's getting better. It's getting better.
Depending on how far the trip is and how much fuel we need, we can stack roughly 600 kilos of passengers and cargo.
What's the translation? How many pounds do you know roughly?
1,300 pounds roughly.
So you carry about 1,300 pounds of freight.
And unlike the airlines, we don't fly quite as high, so it's a requirement for us to wear a life vest.
Flying doesn't make me nervous. I love it. It's good fun. The little planes are better than the big ones. When he always takes us on like a different trip around the island. You see some amazing parts of the island. It's just beautiful. So you front the plane, you see some amazing oceanside and parts of the island. It's just beautiful.
All right, to be continued. Thank you, guys. A lot of trust in you here.
Okay, thanks everyone. We'll keep going. Okay, next up we've got zone pressure reduction systems design considerations from Lawrence. Thank you.
Just bear with me, I'm going to bring that microphone down a little bit. So as Brian said, I'm Lawrence. I look after the Zern products for the Reese Group throughout Australia. That covers backflow, PRVs, TMVs and flush valves. Tonight we'll go through some design considerations around pressure reduction and PRVs and try to bring a bit of simplicity to a field where finding is becoming a little bit more difficult in Australia as we're transitioning from current design practices to newer design practices. Some of these are already in place around the world, and we're wanting to bring some of those elements to the Australian market and improve our outcomes for our users, for our plumbing contractors, and for our designers as well. Normally with this presentation, I have questions coming backwards and forwards throughout the presentation, but we'll keep them to the end tonight. So if you do have any, try and hang on to those till the end. So we'll get going through. What I want you to think about through this is start thinking about some of your, for the contractors here, some of the installations you've done or some you might have coming up. And for others, the designers, any projects you're working on, have worked on, or you might have in your pipeline as well, and how we can apply some of this new knowledge. Some's old, it'll reinforce what you already know, and some will bring some new elements to it as well. So what I want you to think about is pressure reduction and using PRVs. Is it complicated or complex? Now, I won't go into an English lesson tonight, but let's work out the difference between the two and how that comes to play in design and in your installations as well. And this can be the same for your maintenance crews. So you might have existing buildings that are 5, 10, 15, 20 years old,
And you've got to essentially redesign a system to make it run more effectively under today's considerations. So we'll start off very, very simply with what PRVs don't like. Okay, it's pretty simple, but some of these we don't often think about too often, we take for granted. Most fixtures in plumbing don't like debris, we all know that, but it's a very common problem throughout plumbing. High velocity is an issue in Australia. So we generally operate at higher maximum velocity limits than other countries around the world. So the US and Europe in a lot of places, for example, will limit to 8 feet a second or 2.4 meters a second, where we'll run to 3 meters. And peak velocities can far exceed that as well. So you'll get random times of the day, it's not predictable, where those velocity limits will actually spike well and truly above 3 meters a second. And we've even had some where you've got negative as well. So creating I guess a siphonage effect on the fixtures too, which can cause their own problems. High temperature is another one. So now I'm not talking boiling temperatures, I'm talking 60 degrees, 70 degrees, 80 degrees, which is very, very common in hot water systems in Australia. We're finding around the world, particularly in the US, they won't subject those valves or fixtures to that higher temperature. They'll try and control things before the hot water, not after. Another big one for us in Australia is demand, so low flow. Are we considering flow demands of the use downstream as we're moving to more efficient tapware and endpoints for our water systems? Are they actually opening valves up enough, or is the demand too low so these valves aren't functioning correctly? We need to account for that. That leads into the next one, which is piping, okay, getting the sizing correct, so then sizing the valves correctly. Often in Australia, and you'll see this throughout the presentation, we're worried about delivering enough water and enough pressure to the most disadvantaged fixture, which is a good reason to have concern, but we often oversize everything to make sure that last fixture is getting enough water. We're not considering the effects that has on the other fittings and fixtures throughout the building. Then we get the common one, so water hammer thermal expansion. This can happen within a system. And one that's not so well accounted for in real world practices in our experience is imbalance. So with PRVs, as you've learned on this journey, they react to the system, to what's coming in. There's a direct reaction to what's coming out. So it's important to have balance into the valves, hot and cold, as well as coming out the other side. Okay, so just touched on those. We'll jump onto what PRVs do like. Very, very simple. It's almost the opposite of what they don't like. So we like clean systems. We want to make sure that the systems are flushed before valves are installed. Now, this can be very, very hard on major projects. I think some tier one contractors out there might be doing high-rise buildings. Obviously, everything's built from the ground up. Put all the valves in on the lower levels as they're moving to the floor above, cutting in new lines, flushing all that back down to the valves below. So we often find debris is a massive culprit for warranty claims, valves not working correctly, pressure creep and noise. And usually it will be 6 months, 12 months, 18 months down the track. It's always the end of DLP. Tends to coincide with that time frame quite nicely. So it's not always immediate, but there's something that's happened at the time of installation. We want to keep velocity friendly, so we want to make sure we're looking after the fixtures and the fittings in the system, making sure we're accounting for organisms and growth. Of course, we want to try and prohibit those from growing in there, so we've got to have certain speeds within the system, but we don't want to go so high as to wear things down quickly. We also don't want to create situations in the building where you're actually speeding up velocity naturally. Okay, so I want you to think about that through this presentation too. Okay, think about large openings into smaller ones. Just drop down there. Sorry guys, not sure what's going on there. Yep, get the tech expert. It's not on any appropriate site. So no, that's all good, mate. You're clear. So we want to get that velocity to a nice friendly limit there and that balance point. We want to make sure there's adequate demand. So have we got enough draw downstream from your tapware that's going to open up the valves to a point where they're operating in the right zone for them? Sometimes that means stage reduction. So we need to actually bring down that pressure in stages. And we also need to control the velocity in those stages as well. As I mentioned, balanced systems. And the last one here for the contractors in the room, even for the consultants as well, is maintenance. This is probably the most overlooked aspect of PRVs we find in Australia. Now, This isn't brand specific. At Reece, we get the benefit of working with a number of brands out there, and we have a lot come through our system. And we do find the number one cause 18 months, 2 years, 3 years, 5 years down the track is there has been no maintenance. Now, majority of pressure reduction manufacturers around the world recommend annual inspection and maintenance of their valves. So inspect them at least annually. And that's something we're asking designers and building owners to start stipulating around the management of their building to make sure that's contracted in there. So maintenance companies aren't going out and putting their hand out saying, hey, I want more money. This is actually a requirement by the manufacturers and designers to maintain a system to work properly and make sure there's no problem, and actually reduce the cost of life or cost of ownership, not actually have it increase. So that we're looking at a win-win situation there, but we need to start at the early stages of the conversation. And bear with me because again, we're not working. There we go. Let's check that, make sure we got it. So I'll just touch on now, you don't have to read all of these. I know some people are auditory, they'll pick up things by hearing and others will pick up things by reading, but some of the common design we come across in Australia, and this is not always, this is just some of the common ones we see. We often have large pipe sizes, as I mentioned, to accommodate the most disadvantaged point. We have high velocity limits, and most commonly we often use just small valves. So think about maybe apartment buildings you've come across where you might have it might be a high rise, it might be only medium, but you'll have maybe 10 apartments on a floor and you'll just have a 20 mil valve, hot and cold, at each apartment. That's all you'll have. There'll be none on the rises. There's no other control. It's all just going through a 20 mil or even a 15 mil valve or a mix of both. That's one of the most common design setups we see in Australia. And that's something I'm wanting to change. And I think a lot of manufacturers will start getting onto this, particularly from America and from Europe as well. You'll start seeing that stipulating their designs. And insurance companies will start actually backing a change as well because they're seeing a lot of leaks and a lot of problems due to a design with just small valves involved. Where we are using larger valves, I think sometimes even simple processes like a townhouse complex, you might have half a dozen or 8 or 10 townhouses, and you might have just a single feed that's a 40 mil or a 50 mil pipeline into that complex, and there'll be no low flow bypass on there. So you're just operating a large valve. Okay, some of the minimum flows they require are quite high, and using a single tap in the middle of the night won't allow that valve to operate properly. That causes problems later, so keep that one in mind. So where there's large valves, are we using low flow design, which I'll show you in a minute. We use high temperatures. That's pretty self-explanatory. It's pretty common. We don't like having to wait for our water. We don't like having cold water at the most disadvantaged point, so we'll jack up the temperature. We'll run between 70, 75, and even up to 80 degrees out of the hot water plant. So the lower floors or the last one on the loop before it returns has a nice 60 degrees. But we're not really considering what that's doing to the internal components of not only PRVs, but other fixtures as well. And as I mentioned, we don't maintain or inspect our valves very well in Australia. So it's something we need to change. Now, this next one, before I go on too far there, we'll just have a look at that picture because they do tell 1,000 words. So this is a valve we had returned from a project in Queensland. And it was at the DLP period or coming up to the end of the defect liability period for a tier 1 contractor. So this was a major building, very, very prominent. There was a lot of eyes on this building. It was one of the first Green Star buildings. Just coming up to that I guess, DLP period end where the retention bonus is on the line. So they're going to get their money back or not based on the defects and things like that. And of course, the valves start making noise and we start getting pressure creep. So worst thing that can happen in pressure reduction is it doesn't hold its pressure. You have an excess of pressure downstream, hoses burst, floods, damage. That's the problem. A precursor to that often, not always, is noise. So you'll start hearing that very high frequency humming noise, chattering, whatever it might be. And then if that's not addressed, it'll go to a stage where the pressure's creeping. Now, this one here, of course, it was the valves are faulty, the valves are faulty, the valves are faulty. Come up and have a look. What we did do at the same time was got some of the valves removed because we want to inspect them because there are times obviously where the manufacturers do have issues. We want to make sure we catch those quickly as part of our quality processes. In doing so, we took this apart, and as you can see in that middle picture, what did we see there? Those big chunks of debris. Now, this was one of those cases where I talked about not flushing the system correctly. It's not an easy thing to do. I have lots of problems with no solutions. So we haven't come up with a great solution for this one yet on your multi-storey buildings, but it was the lower floors. And this tier 1 contractor, as they moved up the building, were tapping in new lines, and that copper swarf was flushing into the valves below. Even though they were flushing the floor they were on before the valves went in, it was flushing into the lower floors. Now, they threw the question at me, well, why is it only happening 12 months later or 18 months later? The answer to that was, if you think about the rubber surface, when it's new, it's quite soft. Right? So you've got a bit of elasticity in that, and it actually rebounds to its shape, and it will hit the seat and seal. That's how the pressure reduction valves work, essentially, without going into too much detail. Over time, that copper sitting in there, so it would absorb around that copper and it would seal. Then combined with high temperature, we vulcanize the rubber or have something occur called compression set, where the rubber becomes hard. It can no longer seal or form a seat around the metal components that seal. And that's where the noise starts to come in if you're lucky. If you're not lucky, it's silent and the pressure just creeps up. In this case, we had both. All right, so that's why it took longer. So they're not always prevalent at the time of installation. They don't always happen soon after. It can be 12 months, 18 months, or even longer. So it's something that needs to be considered beforehand to make sure we minimise the chances. All right, and then some of the other ones you can see there. If you look at the one with the person holding those two O-rings, yes, they are two O-rings. I don't know if you can see the guys in the back. One of them is nice and round, and one of them is like a flat washer. Right, that's that compression set. That's an example of the rubber not having the elasticity anymore when it's exposed to constant high temperatures. And when I talk about high temperatures, I don't mean 90 degrees. I mean even 60, 65, 70, 80. Every degree above 60 will impact the polymers and the elastic properties of rubber. And this is common across all manufacturers, regardless of the rating of the valve. You know, just because on a spec sheet it says it can handle 80 degrees, it doesn't mean constant. It means in use, and then there should be a cooling period. No manufacturer could guarantee that a rubber will last 80 degrees with a constant temperature. That will happen very, very quickly, and it can be in the vicinity of a few months up to 5 to 8 years. Sometimes it can last quite a long time. It just varies quite a bit. So keep that in mind. So once you get that compression set, can't hold its pressure. If you're lucky, you get noise, someone in the apartment complains, you can fix it, you can address it. If not, you get a burst hose, flooding, insurance companies get involved, and everybody down the line is impacted. Okay, the next one we're going to look at, I'll jump ahead here because we've done the, I guess, the temperature. And one common thing you'll see there is increased wear. All right, so a lot of these elements actually involve wearing down a valve. It's not that a valve's faulty. It's not necessarily that a system's bad or good. It's just they're wearing these products quickly. So we need to reduce that rate of wear. All right, so the issue, again, not staged, so we're not bringing down that velocity and friction to a point where it's managed properly. We're not accounting for the demand, as I mentioned, low flow. Keep that in your mind, that's coming up. And sometimes, quite commonly, we don't have protection against water hammer. Right, so you'll see in a minute the different types of valves. Particular valves with diaphragms in them, when they have water hammer, they lift up and down. Now, there's a finite number of cycles these valves will last. And if they're getting constant hammer from a washing machine, even taps shutting off, or even thermal expansion, that water pushing up against them, they'll wear quicker. Sometimes they get a hole in them and you'll get leaks. Other times you'll just get that noise, or you'll get the compression set increasing, and then you'll get the pressure creep as well. And again, no maintenance. I'll quickly jump into the types of valves. Now, these are not brand specific. There are multiple manufacturers of each type. It's not focusing on brand, it's focusing on the actual mechanisms that I guess they're engaged to control the pressure. So you've got your pilot operated valves, which are your automatic control valves. And some of the brands you probably all know out there, Burmad, Challenger, or Claybell are probably the most popular in Australia. These will open up, so they react to the demand in the system and the supply. So they'll react to open up more. If there's a drop in demand, in supply, it'll open as much as possible to make sure downstream the demand is supplied as consistently as possible. Okay, so think critical systems like a dialysis unit in a hospital. They'll often have these specified in, and for the consultants, I'm sure you've probably come across them, to make sure they've got as much water as they can have, regardless of the supply. It's not magic, it doesn't produce water, but it'll open up according to that supply and also according to demand. So if demand increases or decreases, those pilot valves, that little brass valve you can see above the big blue one, that'll open or close the main valve. Okay, next we have direct acting PRVs. We have two types, diaphragm operated and piston operated. Okay, the diaphragm are quite forgiving. They're probably the most common in Australia, although we are seeing more and more piston operated come into the market as well. The diaphragm operated, the benefit to those is they'll accommodate fluctuations in both inlet and a bit of back pressure. So if you're getting thermal expansion or a little bit of water hammer, some of these will actually lift a little bit and let a bit of that pressure back through. So if you've got a static system, so you've got hot water that's come through, it's sitting in between your tap and your PRV, so somewhere in the dwelling and the PRV, and that pressure builds with the thermal expansion, of course, as we know it all expands. That'll actually push back on the PRV, and these diaphragm ones will often lift and let a bit of that pressure off back through the valves. It's not a bad design feature to have. But of course, the downside is that will wear the diaphragm quicker than it would normally. Then we get into piston operating. So these are very, very robust valves, but they're not quite as forgiving. So they need a stable environment to operate in. If you give it a stable environment, these will outperform almost any other style of PRV. But if there is fluctuations, so you've got high rates of inlet fluctuation or demand stopping and starting downstream, these will tend to wear quicker. So you need to make sure you're designing your flows around those correctly. We'll skip over these. Now I'm going to get you guys to focus a little bit. All right. Now you remember at the beginning I talked about complex and complicated. So I won't get anybody to be in the spotlight and actually tell me the difference, but there is a difference between complicated and complex. Okay, and I want you to think, are these complicated systems or are they complex? Okay, and you can read ahead if you like. Complicated problems, pretty simply, are predictable, controllable, and designable. Okay, so I want you to think about an IKEA piece of furniture, also a Lego set, right? They can be quite complicated, but there's a standard set of procedures or instructions and you get the desired end result, and it's repeatable. Okay, so you can design that, you can follow it, and you get the same result 9 times out of 10 unless you're missing a screw or a piece of Lego. All right, so that's complicated. Complex is a little bit different. Okay, they're unpredictable, self-organizing and self-emergent as well. So it can occur at any time in any way, shape or form. Now that can be very difficult to design around because you can't necessarily create a standard set of procedures or instructions that will guarantee the same desired result. Right, now, what I will hammer home here as much as I can is PRV systems are complex. Okay, you can design a system the same way 100 times and get 100 different results in the real world, even though on paper it should be the same. There's so many idiosyncrasies to those designs, you're never going to get it right. So what are those complexities and how do we improve them to create a better design in our PRV systems? You're never going to get 100% rate here. We want to bring it down to an 80-20 as best we can. So if we can bring you down to an 80% success rate where you've got most of your system parameters accounted for, and then you might tweak things based on a system. Those little idiosyncrasies, you can play with that 20%. Don't worry about reading all of these. I've touched on a lot of these already. This is just more for my notes there. But some of the key ones, we want to make sure we're getting the pipe sizing correct. Okay, in Australia, it's very, very common, particularly in high-rise buildings, to have very, very large risers, somewhere around 4-inch or 100 millimetre, maybe even 6-inch. Then you might have 40 or 50 mil branch lines and then 20 mil droppers to the apartment. Now, I mentioned before velocity and orifice size or opening size. So when you go from large pipes down to small openings, you actually increase the speed of that water or the turbulence of that water. And some of these terms you'll see again throughout, cavitation being one of the results of that. So if you're operating at 3 metres a second, I don't have the maths here, I'm not an engineer, already at the limit, and then you then go from 150 mil pipe, and the first point of restriction is essentially a 20 mil PRV, and it's not open all the way. You've got 150 mil worth of water, 50 mil worth of water, 20 mil copper worth of water going through about 2 millimetre opening inside a valve. Imagine the amount of friction and turbulence you're getting through that. It's like a high pressure hose, it's almost a jet. Has anyone here seen wire draw in copper or brass? We have these channels just pulled through the metal. That's created by these. Okay, because water wants a path of least resistance. So if there's the tiniest opening, it'll go through it. But as it goes through tiny openings, we're speeding that up. We're making the water angry. Right, remember before I said friendly systems, that's what we're trying to create here. So if we have large down to very small with no earlier controls or staged mechanisms, we're increasing the speed of that water. Add in hot water and it's 10 times more prevalent. The AS 1379 actually mentions that. It's up to 10 times more prevalent to experience cavitation on hot water that is cold, which is quite often why we'll see warranty claims on hot, not on the cold side. Okay, so it's important to get the sizing right to begin with. Do we actually need that much water flowing around to account for a 9-litre shower at the end? Okay, we've just got to think about those things. We want to try and reduce, as it says there, the cavitation and velocity effects. So cavitation on hot water is the bubbles that occur with turbulent water. Now, for the press guys in the room, and Steve, I learned this from you through Conex Banninger, when you've got a burr on your press systems, that obviously can increase that turbulence as well and help create these bubbles. Now, those bubbles don't explode, they implode. So imagine that sitting on a rubber washer or seal ring inside a valve, and that rubber implodes. Over time, it creates thousands of little pits in the rubber and it can no longer seal. It's essentially like having debris there, except it's the opposite, it's negative. So you're then getting the same issues. And that's 10 times more prevalent with hot water. So we've got to make that even more friendly by sizing it correctly to begin with. Okay, we want to have our inlet pressures balanced. I mentioned at the start about balancing. Now, we had a job in Sydney a few years ago where valves were wearing every sort of 18 months to 2 years, and they couldn't figure out why. What we found out in the end was we had a massive inlet pressure difference. On paper, it should have been correct. It was a pretty common system design. Had cold water pumped in at the basement, boosted to the roof, hot water up the top, and then fed down. So pressures going up should match pressures coming down. What we found was between hot and cold, there was a 300 kPa difference inlet to the valve. Okay, I can't remember which way it was, but that could be, for example, you might have 700 kPa coming in on cold and 1,000 coming in on hot. Right, now, a little known fact, and I want to really hammer this point home too, when a valve says 500 kPa set pressure or preset from the factory, that doesn't mean it's plug and play, put it in, it'll be 500 kPa outlet no matter what. PRVs react to the inlet. They're a direct acting PRV. So they will be set at 500 kPa out only at the same pressure the factory set it. So if they have 700 kPa in at a certain flow rate and you have the same on site, yes, you'll get 500 out. If for every 100 kPa above that inlet pressure that the factory uses, you'll have a 10 kPa increase on your outlet with no adjustment. Okay, so let's say the factory sets it at 700 kPa and it's 500 out, so 700 in, 500 out. And we then have a site that has 1200 kPa, that's 500 difference compared to what the factory set it at. You're already at 550 out, which exceeds the Australian standard. There is a plus minus in the Australian standard of 10% as well. So we could be sitting at 600 kPa out on what was 500 kPa preset by the factory. Not a warranty condition, not a product fault, that's a site condition. Okay, because we need to allow for that, that plus minus, but also the adjustment. So that's why in yellow there, I don't know if everyone can see that, but I'll jump to that one. All PRVs must be set on site to site conditions. You'll start seeing more and more of this where manufacturers won't pay warranty claims where initial installation or adjustment isn't evidenced because they're not set and forget. They won't stay at a certain pressure if they're not adjusted to the system conditions. Okay, so I'll just relay that back. So inlet pressures, we want those balanced. We want them ideally within 75 kPa of each other because of something called fall off. That's the difference between static pressure and dynamic pressure. You'll see a drop on a gauge. Generally, it's between 50 to 75 kPa for most manufacturers, but it does vary. And want to have that balance. Now, part of the hot-cold balance, has anyone here ever had a client complain in an apartment building, one apartment, that they have got really hot water or really cold water and they just touch the tap and it completely changes? Or they turn the tap and it takes forever to change the temperature? Often it's, everyone looks at the tempering valve or the tap or something else. Often it's or even the pressure reduction valve, but it's before that. So you're having an issue with the balance of supply. So you're getting far more on one than the other, even though on paper it should be correct. Real world's very, very different. So we actually need to go back to the beginning of how this water's supplied and make sure it's balanced in so it doesn't create an imbalance out. Next one I'll touch on there is reduction ratios for the designers in the room, even for the plumbers. So that's the amount of reduction you can get out of a valve from inlet to outlet. And we want to keep that at a ratio of 2 to 1. Really simple math. So if you've got 1,000 coming out, you can set the valve at 500, 1,000 coming in, you can set it at 500 out, it's going to run smoothly. Most manufacturers have a limit of 3 to 1. Okay, so again, I'll try and make this simple maths, it's getting late in the night. If you have 1,500 kPa in, you can reduce that down to 500 kPa as a maximum. You can't go any lower. If you go lower, you'll start exceeding the physical parameters of the spring and the system becomes unstable, and you'll also increase the rate of wear. So if you have a system where you've got high pressures, say 1700, 1800, and you want 500 at the apartment, you have to stage it. You've got to bring that down in stages. You have the first valve at 800 outlet, your next valve at 500. And that'll serve two purposes. It'll also help control the velocity a little bit as well. But make sure you stay within that friendly reduction ratio zone. Next one I'm going to jump to, or a little one there, is the 100 kPa difference between inlet and outlet. So have a think about some buildings where at the top you might only have 530, 540 kPa on the top floor. Yet I've seen this time and time again, there's a pressure reduction valve there set at 500. And that'll wear out because it can't open. it's only got 40 kPa difference between what's coming in and what's going out. Okay, you need at least 100. That's to account for that fall off between your static and dynamic, all right, to make sure the valve can open enough to not cause premature wear on the valve and to give a stable result to the client as well. If you've only got 540 coming in, for example, and you set it to 500 out, they're not going to get a stable, reliable pressure. All right, so don't forget the end user in this piece. Okay, anyone that has an apartment out there, you don't get to choose what's in your apartment. You buy it generally, off the plan, or later on, you don't get to choose the valves and fittings and fixtures that have gone in, but some of these things can have an effect. So any plumbers out there, if you get on a top floor and it's only 530 or so in, you could make a choice and remove those if you want to. That's up to you. Or you can just reduce that down to 430 out. So you've got that 100 kPa difference, just to make sure you've got enough to allow for that fall off. Low flow tapware is my next big bugbear. So again, talking about velocity, think about large pipes going down to smaller 20 mil dropper, and then opening up just a little crack of a tap. You might only get a litre a minute, not even. Middle of the night, it's going to be less. So the valve's not opening. That's a 20 mil valve. Imagine a 50 mil valve on a branch line. This might require 40, 50 or 60 litres to open properly, and all of a sudden you've got 0.2 of a litre coming out. Okay, the demand, it's not going to open. So you've now got 150 mil riser. You've got the 50 mil water flow going through an opening that's not even a millimetre. Okay, that's increasing that velocity to huge extents, creating a lot of friction. That's going to wear very, very quickly. All right, in the vicinity of months, you're going to be getting, someone's going to be getting a phone call saying this valve's not working, it's making noise, tenants are complaining, pressure's creeping, the hose burst, there's a flood, whatever it might be. Okay, simply because we haven't opened that valve up enough. All right, we've got to account for the low flow and the high flow demands. We've got to account for the whole range. Already touched on the extended temperature exposure to high temperature. We want to try and make sure we reduce that. In the US, we're finding more commonly they'll control the pressure before the hot water, not after. Whereas here, often we'll control it after the hot water, and that's killing valves and all sorts of things afterwards, really reducing the life of the product. So we might need to have a play with design changes there. That's something to look for. That will come. And a lot of standards and codes in the US are written by insurance companies, and kind of makes sense for good reason, right? They're the ones paying out all these costs when things go wrong. So they want input as to the standards of best practice, how designs should happen, how systems should, installation should happen, how designs should be conducted, because they're the ones footing the bill if something goes wrong. I think we're going to see that come to Australia in the next 10 years. We're going to see more input from insurance companies, and we're starting to see it now through owners corporations, body corporates, where 4 or 5 call outs or claims later, they're now saying to buildings, fix the pressure reduction or we're not covering your building. Right? And tenants in the meantime are seeing their fees, their strata fees go up huge amounts to cover that cost. All right, the last 2, back pressure, dirt and debris, are pretty simple. I'm just going to jump in now to make this a little bit easier. How can we, with all those complexities, all right, and it is complex, not complicated, remember that difference. How can we make this a little bit easier for everybody here, for the industry to control pressure safely and to get good outcomes for the end user and also for the designers and contractors installing? So a few of the main areas: correct installation, number 1. If we can fix that, we're going to solve a lot of problems. Velocity and cavitation, let's control those, and the low flow. If we cover those, we've done that 80%. We've brought the complexity down to 80%, then we can tweak where we need to. Now, this is in a manufacturer's installation instructions. It might actually be Zern, but you're going to see more and more of these come across all other manufacturers moving forward if they're not already there. We've got to make sure that all valves are adjusted at the time of installation. Okay, the call for this is now going to come to the industry where it will void warranty if it's not evidenced. There'll be no need to pay out any warranty claims from a manufacturer's perspective if that's not done. That will be a requirement of the manufacturer moving forward. We're going to see more and more of those. Now, it's not a blanket black and white statement. Again, it's complex. There's so many facets that come into this, but it is certainly a consideration. So we need to make sure we're ensuring best practice from time of installation through to after sales and follow-up, but also the design prior to the installation as well. Can we stipulate that in? Okay, one thing I might add there too is set them under flow. For any contractors in the room who set PRVs or install them, don't do it static. Okay, for anybody that hasn't, when you do, I guess, an installation of a PRV, it's static. You'll be adjusting the thing with an Allen key or the adjustment bolt, and nothing will be happening on the gauge. It'll just be sort of sitting there. Might be just slightly bouncing. Okay, you leave it there, you adjust it, you go home. Tenant comes home at night, opens up the tap, turns it back off, and now the pressure's all over the place because you don't really know what you set it to because it wasn't doing anything under static. It's got to be under flow. Okay, so always open a tap and then set the valve to that 430, 440, 450 mark. Remember that 75 kPa I mentioned. And then turn it off, and then you should see it sit 500 static. That's the correct way to install them. Won't go on too much about this chart here, but it does show the reduction ratios. You've got a nice normal operating zone, and then you've got conditions outside of that, as I mentioned before. So you want to keep it 2 to 1, nice and friendly. And also the other caveat to that is anytime you've got more than 1,000 kPa coming in, you want to stage your reduction. Even though a valve can handle greater reduction ratios, it can handle 1,500 in and still come out at 500. Anytime you get over 1,000 kPa, we find we do have a really increased rate of wear based on the velocity generally and the amount of water moving through small openings. So it's always best to try and stage it. You simply have 2 valves in series. First one set 800 out, second one set at 500 out. Okay, so it's bringing that down nice and friendly, so it won't affect the valves in a negative way. You've still got the desired outlet pressure, but you just bring it down in a friendly way to reduce that velocity and effect on the valve. Okay, one thing you've probably seen throughout this, I don't know if anybody's been reading, but you see a lot of the word wear in there. Okay, that's how these things are failing. It's not instant, there are product faults, of course, but it's not a product fault. It's just wearing down the internals. It can't do its job anymore. So we're creating systems that are actually wearing these valves far quicker than we should. All right, so a couple of things to consider there. Now I'm going to throw in the low flow or the flow demand. All right, so this is, not all manufacturers do divulge this information. I don't know why. If they don't, you do need to ask them for it because it's crucial for your design, particularly around low flow. Okay, so let's have a look at, say, we'll just look at the small bore range, so your direct acting screwed brassware style size that you'll see on branch lines and droppers to apartments. Let's say you've got a 100 mil riser, might be 30-story building, something like that. You might have a 40 mil or a 50 mil branch line before you get to your 20 mils or 15 mils to your apartment. Let's say 32 litres a minute. How many showers is that running before you're going to get to that point? 3 and a bit, maybe 3 and a tap somewhere, right, to get to 30 litres. That's before the valve opens properly. So let's go to 2 o'clock in the morning, all right? You've only got a branch line PRV, which is not a bad design, just putting them on the branch line. I'll get to that in a minute. 2 o'clock in the morning, someone goes to the toilet, that's fine. Then they're going to wash their hands. They don't want to wake everybody in the apartment. So they just crack the tap quietly. All right, they just leave it just trickling just enough to get the soap off their hands. What are we going to be running at there? 0.2 of a litre, not even, all right? And this valve needs 32 litres to open. Okay, so if you think about this velocity, I mentioned a small orifice, large amounts of water through a small opening. We've made this opening really, really small. All right, that thing's going to wear out very, very quick. All right, so we need to have low flow design into it. Simple way is you have your large valve and then you have a smaller valve plumbed around it, set at different pressures. All right, so the smaller valve will open up under small demand. As soon as the demand increases, 7 a.m., 7 p.m., everyone's showering, cooking, using a lot of water, the large valve opens and then you've got a nice smooth response. Okay, and that's what we're trying to create with these things. So keep in mind that low flow. All right, we're nearly done. We're going to get to the design element here. Now, for any of the designers in the room or even contractors, this next one, it's on the screen. It'll be clear, but if you do want to spend some more time having a look at designs and how to change it, feel free to get in touch and we can get in depth on your projects on these. So, as I mentioned at the start there, some of the common Australian designs are 20 mil PRVs at each apartment. That's about it. There's no prior control. It's all just a high volume of water, high speed water going through 20 mil valves and that's it. That's the most common we come across in Australia. There are elements where there is branch line PRVs and there's multiple versions of that around, which is great, but we need to make sure it's done correctly as well. So I mentioned a couple of things, right? So I mentioned above 1,000 kPa. So you'll see option A here where you've got the top one with above 1,000 kPa and the bottom one is less than. So above 1,000 kPa, you'll stage it. So you'll see the dark orange one there. That'll be set at, say, 800 or 750 out. And then you've got your next one in series, the lighter orange or yellow, at your 500 or 450 out. Okay, so that's bringing that pressure down in stages to be nice and friendly. Now, how a low flow bypass works there, you'll see the difference between the small one and the large one. The small one set at your outlet pressure will just go to the 500 kPa, the maximum outlet pressure you want. So when you've got just a small tap opening up downstream, the pressure won't drop below that. Okay, when you've got all your showers opened up, all your taps opened up, the demand will mean there's not enough supply, so the pressure will drop. That's when the large valve will open and we'll start bringing enough supply through to account for that. That's how you get the smooth response through the whole flow curve. Okay, so small taps will open up the small one, Once the demand increases, it'll open up the large one. All right. Now, if you think about a building where you might have 10 apartments per floor, if you put 20 mil PRVs in hot and cold, that could be anywhere between 200 to 1,000 valves. All right. That's a lot of valves. Great for manufacturers sitting in the room, all right, to sell 1,000 valves. Not great for anyone who's got to maintain them or the building owners. That's 1,000 points that can go wrong, that wear down and need maintenance, okay, or issues that could cause leaks or damage later on. With branch lines, you might only have 2 or even 4 valves per floor. Okay, so the cost of ownership now is reduced dramatically. The initial cost is probably similar because some of these are higher spec valves. So your initial cost is no different. You're no worse off. You're probably better off in most cases. But cost of ownership is dramatically reduced. Far less things to go wrong, far less maintenance every year. Because remember at the start there, I mentioned they need to be maintained every year or inspected every year. Now there's far less to maintain. Imagine a plumbing bill to inspect 1,000 valves a year. No body corporate's going to pay for that. Right? But if all of a sudden we've gone down to 200 valves or 100 valves, now it's feasible. All right? So that we're trying to create that friendly environment. So always put them on the branch lines is the recommendation. If you've got existing designs where they're at every apartment and you're getting problems, work your way back. Go back to the branch line, install them there, and then you can in fact remove the PRVs at the apartment. You don't need to have those small ones. Or if you want them there, that's the next option you'll see. You can leave them there, but it's still better to have the PRVs on the branch line on the floor. And that brings me to this next one here. So what we've seen, particularly around Melbourne and Sydney, but we do see them in all states, where we've got those existing buildings with just your 20 mil or your small PRVs, and they are having problems, or they do this training and realise they need to make a change to protect their system, they will retrofit branch line PRVs and leave the 20 mils there. Okay, so according to the Australian standard, that'll give us a good control, right? We're still going to deliver at least the minimum requirements at the most disadvantaged point, but we're going to have no more than 500 coming in at the front end. It gives us a nice level of control. We're bringing down the reduction in a controlled way at the first 2 on the branch line, and then we've got individual control of the apartments as well. So if the last apartment's complaining that their pressure is really weak, you could open theirs up a little. If they're complaining that the temperature's not right, remember we look back at the balance, but you've got that nice individual control. This is a good middle ground. All right, but when we show the Americans, the design and Zern is American, that's where we're getting a lot of our feedback from their engineers. We show them designs in Australia, and their comment was, we see more warranty claims out of Australia and Canada who design like this with all these 20 mils than we do in the American market. Their market being 10 times the size, and we have more warranty issues in Australia than they do. And that highlighted this whole conversation. We need to start changing our designs and making their systems more friendly. So let's remove the pain points, remove the issues with velocity, with all these reduction ratios, with too small a valve for too large a pipe, and stage less valves on the branch line. It's going to make things far easier for you. Okay, I'll let that sink in for a little bit. As I mentioned, if anyone wants to get in touch, has any projects on the table, things they're working on currently or will be in the future, I know there is a lot more to it we can touch on, and it is complex, remember, not complicated. So if you want to get in touch, then feel free to reach out. And I'll throw out any questions if you have any.
What valve would you recommend for a hot water system?
You mean what type of valve, or
what of your valves of a PRV?
It would depend.
Available on the market for
Sure.
hot water.
Sure, it would depend. Some it depends on the temperature rating, as I mentioned. Some are rated at 60, some are rated at 80. 80 is generally the hottest temperature rating you'll get out of a PRV. What I would say is that depending on, again, the variables in there. So if you've got over 1,000 kPa in, if you've got less than, your reduction ratios as well. If you've got a stable system where you know supply is quite stable and you're not having much chance of hammer, I'd probably suggest a piston style, because it is quite robust. If you've got a chance of hammer supply fluctuations, I'd go to diaphragm style. But really what I would urge designers to try and do, and I'm happy to talk about this from the American perspective, is start to control the pressure before the hot water plant, and then move to, can we supply friendly pressure after the hot water without PRVs being installed?
What about if we've got problems where we've been advised that we have to install them on the outlet of hot water cylinders to maintain the
Good question. What you will find in that case is you've got to account for the fact they are going to wear. And I guess the best way to reduce the issues before they become issues is stipulate annual inspection and maintenance. So it doesn't always mean that a valve has to be serviced or maintained, it just needs to be inspected. So we want to set it at friendly reduction ratios for a start. So let's say you've got 1200 coming out. We want to set that at 1200 coming out of the hot water plant, this is. You want to set that at then 500 out, it's still pretty friendly zone, that's fine. But then we want to make sure the maintenance contractors know that's got to be inspected every 12 months at least. But there's no great way to do it where you've got 70, 75 degree water. Depending on the demand downstream, that is going to wear within the space of months or 3 years. I dare say you probably get max 3 years out of it. It's a hard one to answer in that case. That's the complexity of it, because every system's going to be a little bit different. And what we have seen too in our I guess findings with return product from all manufacturers, every degree of temperature actually makes a huge difference to how long it will wear, that will take to wear rather. So we're trying to work on getting some of that data a bit more tangible for designers, so we can say, hey, at 65 it'll expect to last this long, 70 this long, 75 that long. But we have seen even where valves that have been installed in the same system had a reduction of 3 degrees and lasted 9 months longer, simply by 3 degree difference in temperature. So that may even be a consideration as well. So instead of running at 70 degrees, can we run it at 67 or 65? That might be a good way to find a bit of balance between the two.
What am I in live through?
What's the question? Yep, great question. Great question. I think this is probably an industry-wide topic more than just a pressure reduction one. Okay, for those that didn't hear the question, it was around watermark and lead-free. So are we covered, I guess, in our range? Do we have them? And obviously, it's an industry-wide question that's coming very, very quick with the deadline. I don't believe that's changed. If anyone knows otherwise, please let us know. But May 2026 being the deadline for lead-free requirement and having product installed that is watermark lead-free from that date onwards. In our range in particular, yes. Our valves are from Zurn Wilkins in California, so they've had the lead-free standard for some years already, and our Australian standard, I believe, was largely written based on a lot of those parameters. So our valves do comply, and I guess a lot of manufacturers are going through that process already. Some already do, some will make the deadline, some won't, but ours certainly do. Good question, very topical.
The other item, maintenance. You say annual, we don't have any. So we put it in at the meter.
Yeah, correct.
So special training for the maintenance on your side, or is the plumber just, it's not like that like that?
Sure, no, a little bit, great question. So the question there was with annual maintenance, what is the requirement around that? Is there training from, say, manufacturers? I can't speak for all of them, of course. We can offer that, but it isn't very complex or complicated at that point. Most plumbing contractors would know how to maintain a pressure reduction valve. So the simple inspection is it holding pressure correctly? It's set outlet pressure. If it's not, then it would need to be inspected. So they could open the valve up, have a look at it. If it's dirty, clean it. Does it then hold pressure? Yes, you're fine. If it needs to be repaired, most often, 9 times out of 10, it's a repair kit available from the manufacturer. Drop that in, set the pressure again, and you're fine. But certainly not a difficult task to maintain the valve. And really, the stipulation is to inspect them annually. They only need maintenance if they're not performing as they're set. Another good question. Any other questions out there? All right, thank you very much. Appreciate it.
Thank you, Lawrence. All right. Matt Lloyd's back up for round 2. Moving quickly. And he's on it.
I'll just get Ryan to stay here for a minute because I want to get him to help me. Just throwing one quick question in here. First raise of the hand with the first answer for this question is pretty simple. It's a beer related question. So a long neck of beer, and the first hand up with the correct answer. A long neck of beer holds how many mils? It was hand, yeah. So Okay, that's yours. Just hang on to that answer in your mind, everybody, because it'll help you with a question that's coming up. Do we have any, just those three tables at the back, can you give us the names of your tables? Did you come up with anything, or? I'm only asking because the table I'm on's quite interesting. The guys from NWare came up with NWare, which I thought was pretty good. Any of you guys up the back? Oh, ACO, I suppose. Yeah, good one. There's some good names out there. The Rusty Cups. Oh, Rusty Nuts. Oh, yeah. Okay. And in the middle?
We've got Siri Bike, Chris Bike, Renai, and Vegan.
Oh, yeah, very good. Okay. Putting some brains into it. That's great. Okay, well, look, right, so I'm just going to give you quick three answers to those first questions. So the straight line, Alice Springs in a straight line from here is 2,467, and a straight line to Brisbane is 1,791. So you would have had to have had Alice Springs there. And the Boats Brewery, anyone know that off heart or pretty confident? 81, yeah, it was. And the country with the biggest foreign ownership in Australia is Canada with 2.1%. It's followed by the USA at 1.8%, and China and the UK both have 0.8%. So I won't, just at this point of the game, if you could just put one mark next to each of those. So if you're completely correct, you've got 3 points at this stage. I don't want to know who's got 3. I just want to know, has anyone got 0 at this point? Anyone got 1? Yeah, you got 1. Okay, that'll do. So the rest of you know you're doing pretty well. You guys probably have to lift your game a little bit, but okay. So round 2, question 1 is, which building in Hobart is believed to have the most public available toilet facilities? Publicly available. So it can't be a hotel room where you think, well, I'm public, I can walk in and use it. You've got to actually be okay. Just getting a technical backup here. We'll make that Greater Hobart. That's probably going to help a lot of people. Okay, so think about that Greater Hobart. I'll extend that too. Question 2, Ozzy Osbourne, Michael Caine, and another actor, Bob Hopkins, have in common. What do they all have in common? So we've got, we've got Ozzy Osbourne, Michael Caine, and another actor, Bob Hopkins, have one thing in common. What is it? And you can think about where you are tonight a little bit, that might help. So, and question 3 is, this is coming from the first presentation from James. So the products are Australian made, but he did mention where the factory was. So we need to know where the factory was from the first presentation. So question 1 was which building in the Greater Hobart is believed to have most publicly available toilet facilities? Question 2 is Ozzy Osbourne, Michael Caine, and Bob Hopkins have what in common? And question 3 is, where's the factory from the first presentation it was mentioned? Okay, good luck. All right.
Everyone ready to go through the next prezzo, or you just need a quick break? We're good to go? Good to go. Oh, yeah. Okay. Topic 3, ICC. We've got Tom Roberts coming up.
So first I wanted to thank Lawrence because he really set up my presentation quite well, talking about the importance of pipe sizing. It's a big topic and one that I'll touch on a little bit later on. My topic tonight is going to cover both the Australian standards, so the 2025 edition, which won't be used in Tasmania, but it's still available as a performance solution. So I'll talk through what's changed so you can get up to speed on it. Eventually, the industry will be using it, so it's really important to catch up on that. There won't be any sort of NCC roadshows or standard seminars like there has been in the past, so I'm trying my best to get around and use this opportunity to talk about the Australian standards, as whilst I talk about other things that our company is involved in and what's happening more in the international space. So I know a lot of people in this room. I generally present each year. Peter's talking about his picture in the slide. But I get around the world. I've got a fortunate job where I can go present and share knowledge and gain knowledge from around the world in different things. Apart from my normal role, I was the former director responsible for the Plumbing Code of Australia, the Australian Building Codes Board for 10 years. I'm the current chair of the Standards Australia's WS14 committee responsible for 3500, hence the topic tonight. I'm a board member of the Unified Water Label Association in the UK and Europe. So that's the equivalent to WELS in that part of the world, which is a voluntary scheme. I'm involved in the establishment of a new charity organisation from the UK responsible for trying to solve water scarcity and antimicrobial resistance, 2 big topics coming up. I host a YouTube series called The Pipeline. So if you really need something to help you get to sleep, that's a really good remedy for that. And I do presentations around the world and nationally and try and especially focus on plumbing research and gaining more knowledge and bringing the industry forward. I'm sure not many people have encountered the International Code Council before, but we are many things. We have 8 subsidiaries. We have over 700 to 800 staff globally. We're involved in over 100 countries. We basically just write solutions to construction-related problems around the world and work with governments and industry to come up with those solutions in partnership together. Specifically here in Australia and New Zealand, we are a Watermark and Codemark accredited conformity assessment body. We go through all the watermarking process. We own labs, so we test and accredit different products, both in the plumbing and building space. We write codes and standards as well. So we're a little bit like the Australian Building Codes Board. We're a little bit like Standards Australia, and we come up with different solutions, and we use standards and codes as the tool to do that. We do a lot of education and training, so you'll see a lot more online webinars and CPD kind of courses coming out where we can share knowledge from around the world through the platforms that we've got with the local audience here in Australia and New Zealand. And we work really closely with government, hence my background, to come up with solutions and bring some of the knowledge that might be already available internationally to the Australian industry and not reinvent the wheel every time we encounter a challenge over here. So firstly, 3500. So the 2025 edition of 3500 is not an overly significant change for the industry. The way I describe it is bringing the standard up to pace with what is normally common industry practice. There's probably nothing in there that's going to surprise you. And probably from a plumbing contractor's perspective, there's not a lot in there that's going to change their day-to-day job. It's just bringing the standard up to speed and just keeping it relevant is how I describe the 2025 changes. So to delve into some of those particular areas, there's been some changes in specifically the backflow prevention area, looking at atmospheric vacuum breakers and changing their hazard rating, changing their categorization through the standard. Flexible hoses. So put your hand up if you've been somewhat associated with a flexible hose burst before. No one. Well, Tassie's must be pretty good. Yeah, it's a pretty common problem. The product standard itself has been improved. So the way they're manufactured, tested and certified has improved. It's more stringent, but also now there's categories of flexible hoses and you must ensure you're installing the right category of flexible hose in the right application. makes sense. It's probably something we should have been doing a long time ago. Water runoffs. So any plumbing contractors in the room has ever had to unblock a water runoff? Yeah, I'm sure there's many as well. Changes to that part of the standard to really prevent the build-up of struvite in those systems. So different ways to achieve that. You might have a flush volume of a couple of fixed units or a basin downstream, something that's going to cleanse that line. You'll have steeper velocities and you'll have more guidance around that installation process to help prevent that struvite build-up. Miscellaneous appliances, devices and fixtures. So every time someone invents a new product, at the moment we had to change the standard every time. So you had specific installation instructions for each product available. We've put some general requirements in there to say, well, if it's something generally using water or discharging water to either the sanitary system or the stormwater system, here's the key stringency requirements that those products need to meet to be compliant. So you don't need to continually change that standard every time the product's invented. And hopefully that streamlines the process for new and innovative products entering the market, and we can actually keep up to speed with the rest of the world. Multi-building developments. So if you're on a gated community or those types of examples where you have multiple individual tenancies within one property, it should be a lot clearer in there where you need ORGs, inspection openings, inspection shafts, and how you cater for those multiple dwelling kind of properties where it's all within one big property, but there's individual tenancies within. So hopefully that's a lot clearer in the next edition. Polyethylene pipes. So this change won't actually impact Tasmania at all, but we're finding that due to high ambient temperatures, high chlorination rates, and a number of factors, polyethylene pipes were prematurely failing in some areas of Northern Australia. So we've put in some guidance around that in one of the appendices to really understand that issue and make informed decisions on when polyethylene pipe is appropriate, especially in Northern Australia. Some slight modifications around the eaves gutters and valley gutters and overflows from eaves gutters. Not significant. It's very much bringing it in line with what the Building Code of Australia already covers. And there's definitely going to be more work in that space, in the roofing space, in future revisions of the standards as well. There's a lot more work to be done. New materials able to be used for vacuum drainage systems. And one political and topical topic is rainwater harvesting. So Tassie is a really good example. A lot of rainwater harvesting systems here, a lot of rainwater tank installations, but that, to date, the standard has never covered rainwater tank installations. So technically, Tassie has some nice variations to help cover that, but other jurisdictions, it's technically a performance solution every time you put in a rainwater tank. So we've tried to resolve that. Unfortunately, it's going to be informative in the standard. It is informative in the standard, so it's still a performance solution. But at least in Australia, we've got something to point to in the standard now to say, here's best practice, here's some guidance that can be used. And whilst it still informs a performance solution, you've got a nice document to point to solve some of those challenges. I've already talked a little bit about implementation. So the one thing I'm trying to highlight the most is that in different states and territories, the implementation and the adoption of the standard is going to vary quite significantly, unfortunately. Tassie is not going to adopt it as far as I'm aware at this point. That may change in the future, so watch this space. Victoria are already using it, and other jurisdictions are waiting for NCC 2025 to be published and come into legal effect. So watch this space. If you work across multiple jurisdictions, it might be a little bit of a juggling act until it gets better down and we start moving forward through that the years. So one of the things I want to kind of use this opportunity to highlight is the need for constant change with the standard. We've got people from TAFE, we've got regulators here, we've got plumbing contractors, and we've got designers. So a really good mix, and I'm sure everyone in the room has an issue with 3500. There's something that's not clear where you have a different interpretation to someone else. There may be an innovative product out there, but their standard actually doesn't cover how to install it. There might be new design methods coming out, but the standard hasn't kept pace with that. So what is now becoming common practice becomes a performance solution each time. There may be something wrong, but there may be an error or something that's missing or an editorial. And there may be gaps in the solutions, and rainwater is a really good example. Before that, heated water circulatory systems, I presented at a HCAA meeting in Sydney and explained that heated water circulatory systems used to be a performance solution on an elevator stage. Until it's in the deemed to satisfy solution, it's performance based. So making sure that any sort of gaps in what is common practice is covered by the standards becomes really critical. Otherwise, we're doing performance solutions potentially unnecessarily. So how do you make change? It is a very simple process. It's an online form, jump on Standards Australia's website. It's all digital. But if you don't suggest the change, the committee doesn't know about it. So any sort of problem that you have in any of those areas that I've mentioned before, or if you interpreted something different to someone else, we can solve that. We just need to know about it, and we need that project proposal to initiate that conversation on the subject. So you don't need the solution. We just want to know what the problem is. We as a committee, including the HCAA and other industry groups, can come up with what the solution is and draft our way to a resolution, but we need to know what the problem is. So I can't highlight this much more because we're about to kick off the next round of changes for 3500. So if you have a problem, you've got between, I'd say, now and Christmas to get your proposal in and actually see that change make its way through that revision process. So to talk a little bit more through that change process, the next stage from that was a kickoff meeting. So we generally, as a committee, get about 100 project proposals based off the last round. A lot of them can be grouped together as editorial. A lot of them can form a larger project, but generally we can take on about, I would say, 10 to 15 projects in a 3-year cycle. So there's a real big prioritization process to that. We're hoping to implement a few changes in the next cycle where we can actually take on a bit more and solve more problems and improve the standard even further. But that first stage of kickoff is really to work out the priorities and allocate working groups and get the subject matter experts involved. So that's the point where if we have a project on a particular subject, like pressure reduction valves or something, we might tap Lawrence on the shoulder and say, hey, can we be involved in this working group and help us solve some of these challenges? So one thing we want to do more of in the future is actually tap the subject matter experts, which may be in this room, on the shoulder and say, hey, can you get involved in standards development and be involved in the working groups? Drafting goes without saying, everyone gets around the table, debates the wording, make sure it works for all the different perspectives of industry, contractors, designers, regulators, educators, everyone. So it's got to work for so many different uses. So that drafting stage does take time and a lot of negotiation and discussions. Public consultation. So put your hand up if you put a public comment before. Brian, 3 people, 4 people, 5. Thank you. That's good. That's good odds. You're beating New South Wales, so good job, Tasmania. Everyone has complaints about the standard, but not a lot of people will actually put in some feedback and say, hey, this clause is really going to cause the education industry issues, or it might work for a designer, but not a contractor. Public consultation is such an important period. It goes out for at least 9 weeks, 12 weeks if it hits over Christmas like it did last time. Everyone needs to put that feedback in because it's a document used for so many different purposes and it's such an important document for our industry. Everyone needs to have their say on what that final outcome is. So if we get 10,000 comments, we don't quite get that many, but we do get quite a significant number. We will sit down for a week straight, locked in a room, reading every single comment, debating it, working out how we can make that particular clause better. So every single submission is read, considered and responded to as well. So you're likely to get a response from the committee saying, great suggestion, we've actioned that, or no, that's not something that was a part of the change, it might be out of scope and we'll consider it later. So rest assured, it is worth the time and energy putting in a comment. And then we get to ballot stage. So HCAA is a really good example, Backflow Prevention Association as well, Master Plumbers. Everyone has a voting contribution to the ballot stage. So through your industry groups, everyone gets a say on, is this document fit for its purpose? Has it addressed the challenges that we're looking to do?
And we'll go through that balloting process to make sure what we've come up with as a result of those changes post-public consultation meets the needs of industry and every different sector is comfortable with its outcome. Beyond that, we get to publication. So the document will come out, it'll be publicly available, not legally used yet, but it'll be able to be used. So now is a really good example of that, where we have a publicly available document. It's just not legally used in most jurisdictions yet. So you've got the opportunity to get familiar with the changes, make any necessary changes in your day-to-day business, and actually start implementing that before it comes into legal effect, and you've got to strictly follow that. So to recap on that, how to get involved, please submit a project proposal. The more we get, the more we can keep 3500 up to date and up to scratch. Review drafts when they come out for public consultation, submit comments during public consultation, especially if you're interested in being involved in working groups. A call out may come out through the industry groups represented on the committee to say, hey, we need designers with expertise in this field or plumbing contractors with expertise in that field. So if you have a desire to get involved in standards development, the opportunities are there. And even if you've just got a general interest, please reach out to Ryan or Emily and others and say, hey, if there's an opportunity, I'd like to get involved, because the more people, the more change, and the more we can keep the documents up to date and up to scratch. Government's also another opportunity as well. So one of the big improvements in the next round is actually government representatives being involved in the committee as well. So we'll have that direct regulatory link, and it won't necessarily have to go for a third party to be the bridge between government officials and the committee, which will be a good change. So I wanted to talk a little bit about on-site wastewater management, a little bit about plumbing in hospitals and healthcare buildings, and a little bit about data. But I'm really going to focus tonight on pipe sizing. As I said, Lawrence has set me up really well for my presentation, so thank you again. But the importance of pipe sizing cannot be understated. We are pipe sizing in the standard from research from the 40s. We've estimated our peak demand based on a hotel where they had wake-up calls to work out how many people are going to wake up at the same time and how many people are likely to shower at the same time. That's what the fixed units are based on. And we're still relying on it, so are many other countries. So there is a big need to improve our pipe sizing. So how does that get solved? So I'll talk through the process that we're undertaking, but one of the key areas of solving pipe sizing is the interconnected issues all around the pipe sizing framework. So everything from the dependability of water. Do you have access to water all the time at the main? Or may you, some countries only have access to the water main at 2 hours a day. Is that a challenge for you? Water quality and chemistry, water usage behaviours is a big one. Do we use water the same way as the colleagues in the US or the Middle East or Europe? What materials are being used and the sizes available. So sanitary drainage is a really good example. Your minimum pipe size might be 80 mil, but who uses 80 mil? So what is available and how do you accurately size based on the materials available in your particular country? What data is there available to understand how we're actually using water and the behaviours in the bathroom, and some of the HCAA's existing research work has gone a very big step forward in that space to help improve pipe sizing and understand what's happening in buildings. Cultural considerations. So again, how do we use water differently across different cultures? What sizing methodologies are there available? You can use a method like the fixed unit method, or you can use multiple simulation methods. You can come up with different ways of trying to predict what's going to happen in a building to understand what the demand's going to be and what pipe size you need to actually reflect that and accurately size for it. Energy use and climatic considerations are a big one as well. So just because the solution is good now, it may change in the future. So how do you resolve that? So setting up that framework of how do we understand where we are today, there are a number of plumbing codes and standards around the world. A lot of them actually use the same fixed unit methods with slight modifications to them. But understanding where we are now and where we need to go was a really big part of this work. So hence just to give an idea, an overview of how many different plumbing standards there are, I've quickly became very fluent in Google Translate, working my way through that list. More issues in further working through that process is the lack of data again. If you want to have a science-backed solution, you really got to have that data and that science backing your direction and your outcomes. The way that the data is collected is not consistent. So if you're monitoring from a building in Hobart and you might be monitoring in a building in Amsterdam, are you measuring it the same way? Do you have your sensors installed in the same locations? Can you compare that data as apples and apples, or does it actually become apples and oranges, even though you've got two good data sets? Becomes quite challenging. Everyone's doing little pieces of research around the world. How do you bring those jigsaw puzzle pieces together and actually map it out and come up with a bigger solution? Can we use AI and machine learning to come up with, compute some of this complex data and come up with some solutions? We've progressed a little bit further than the knowledge we had in the 40s. So surely we can use some of the tools that are at our disposal now to come up with a better solution. If you do come up with a solution, how do you actually get it used by industry? What's the tools that you could turn pipe sizing into for engineers to actually provide a solution and pathway forward? So that might be standards. Standards is a solution that we're quite familiar with as an industry. It might be software, so pipe sizing software, and it might be training to bring capacity, build capacity in that space. So if you reinvented pipe sizing tomorrow, no one's going to know how to do it. Everyone's quite familiar with and comfortable with fixed units. So that training becomes really important to bring that capacity building up to using a new methodology. And what is failure? So to give an idea of what a failure might look like in a water supply, it becomes quite challenging. So if you don't have enough pressure at the fixture, or you've got too much pressure at the fixture, that might be quite an obvious failure. But if you're in the shower and it's just not coming out to your comfort satisfaction, is that a failure? Or is that, how do you measure that? So if you looked at the many different ways a water service could fail, how would you categorize that? And then how do you use pipe size to make sure it meets all those objectives or all those limitations? It becomes not complex, but definitely challenging. So who's involved in trying to solve this problem? There we have many countries from around the world all getting together on video conference, having meetings once a month, bringing their knowledge from each country together to solve this problem. Each different country's got a little bit of work in different fields, so it's become quite valuable to bring all that knowledge together and find a direction forward, not reinvent the wheel in any way. We've engaged the University of Miami. We've paid them quite a significant amount of money to lead the research field in this space, but that's not to say they're not the only ones doing it. So Deakin University is a really good example in collaboration with the University of Miami, working really hard to solve this problem and looking at different pieces of the jigsaw puzzle to bring it all together. But there are many universities around the world working on the same problem, and we're bringing them all together to solve it. So I mentioned data and the problems of the inconsistency to it. So these are some of the photos from some of the HCAA research work. But we've just invested in buying our own equipment as well to really drive that work forward again. Not only just look at data from buildings in Australia, which we're hoping to set up very soon, but how do we compare that to a comparable building in Amsterdam or Miami or London? So let's move that equipment around and start drawing comparable data from different buildings around the world and start seeing what we can find from that. Can we actually create a global solution, or do we have to make modifications for the way that either culturally, geographically, we use water differently? So I can't stress the importance of this data, but also the importance of monitoring a building in a consistent way so you can compare apples and apples. I really like this, the figure showing, I believe it's pressure spikes. So throughout the day, that's what you'll see in the pressure fluctuations from the building. Ideally, it'd be nice and smooth and predictable, but we have that sharp pressure fluctuation. So if you're looking at creating a new pipe sizing methodology, how do you smooth that out a little bit so we don't have those kind of issues where you have that quite significant pressure fluctuations, or you look at something comparable with flow as well and say, well, we're getting all these really sharp spikes, but we're sizing for that 1 millisecond of time where you get the peak demand, but 99% of the time it's quite low and pretty consistent and predictable. So are we sizing for something that's happening 99% of the time, or are we sizing for that 1% worst case scenario? Something to consider. So standardizing the way we might monitor a building and install pressure sensors. I've picked two of maybe three of the examples that we've got on how you'd go about that. One is what we'd call the basic layout, where you might have a pressure transducer. You might be looking at cold water temperature inlet, and you might have a couple of ultrasonic flow sensors throughout the building. And that might give you a really basic understanding of what's happening in that building. And the way that those sensors might record it might be every 5 seconds. It'll take a snapshot of what's happening. But in those other 4 seconds, you're not seeing what's happening. You could have that millisecond pressure spike or flow rate spike, and you might miss it by not recording frequently enough. So this might answer some questions if you monitored it at this basic level. It might give you a good indication of what's roughly happening in the building, but it's not going to tell you everything. So depending on what question you want to ask, this might give you the answers. Or you might go to a more advanced layout where you have pressure transducers on every pressure zone within a building. You might have temperature sensors throughout, especially with heated water. You might be looking at what's happening with different plants. And you might have ultrasonic flow sensors, understanding what is the demand and what's happening at different areas of the building. Especially important with multi-use buildings where you might have commercial, you might have office space above that, and you might have residential above it. So basically 3 different buildings attached together. So how do you size to cater for the different demands and the different usage patterns? So this one in particular is what we're looking to pursue. We want to actually understand at a very high frequency rate what is happening in that building. We might monitor and take a snapshot of what's happening at a flow rate or a pressure multiple times a second to make sure that nothing is missed. And pressure is a really good example of that because it happens very quickly. So if you're not recording really quickly, you might miss the big peak issue or demand or whatever it might be that's actually causing your building issues, or something that we might need to solve in a pipe sizing standard. So the frequency and the sampling rates are really important. And for both of them, metadata is also important too. So if you had a building like this one, multi-unit residential as an example, what is the occupancy rate? Is going to be a big factor of that. How many fixtures in it? Is it a 2-bedroom, 3-bathroom house? Or is it a 3-bedroom, 1-bathroom house? So you might have more occupants per fixture or more fixtures per occupant. How does that relate? So that metadata becomes really important to understand what the data is telling you from those sensors. So moving from pipe sizing, the other one I did want to touch on is a project that we're going to start next year, is plumbing in hospitals and healthcare buildings. So under every code and standard around the world, we treat plumbing in hospitals and healthcare buildings somewhat similar to every other building. There are some subtle differences, some tapware and whatnot that are specifically marketed for those purposes, but generally the way we design is somewhat similar to everything else. But the risk profile in these buildings is so significantly different. It blows my mind that we would take that approach. We have immunocompromised people in the building, but we also have people walking through the reception, bringing in the diseases we're trying to prevent spreading. And everything's connected by the same sanitary drainage system. We're relying on a little bit of water in our trap seals to prevent the movement of pathogens. With the advancement of antimicrobial resistance, plumbing is the front line of trying to solve some of these pathogen spread events happening before they happen. Because the antibiotics that we're relying on now to solve some of the infections aren't going to work in the future. So how do we bring up the stringency level of plumbing in hospitals and healthcare buildings to help combat that and help pathogen spread before it even happens? So it's something that I think is quite important, and I'll really want to try and drive forward with a new standard specifically for this purpose. And that's it. I did mention how much research is happening around the world and what's so many different events happening. So I did want to give a quick plug to the kind of YouTube channel where I try and meet with subject matter experts and interview them and talk about what's happening in their region. So we've done Belgium, UK, Saudi Arabia, Australia, New Zealand, a lot of experts from around the world where I try and tap into some of their knowledge and just share it in front of a camera really quickly while I'm at a conference. So it's pretty rough and ready, but hopefully I can share some of their knowledge with a wider viewer base. And lastly, we have a newsletter. So it goes out every 2 months, every second month. And again, we have researchers from around the world in the plumbing space writing articles for us, sharing what they've just spent the last 12 months doing, what their PhD students have been doing in the plumbing space. In the next edition, I think comes out this week, we have an article from a plumber that does plumbing in Antarctica. So quite unique stories from different people from around the world. So I really encourage everyone to subscribe to that. You can always unsubscribe if you don't like it, but it's not going to spam you. It's every 2 months, and it's very specific for plumbers and sharing knowledge from around the world. So I'll leave this up until Ryan kicks me off stage, but really encourage you to keep it up to date with what's happening both around the country and internationally through the newsletter. And that's me. I think we're pushing time already, but I'll be around for the rest of the night. So if you've got questions on 3500, if you've got questions on how to make changes, if you've got questions on what's happening internationally with any of these standards, please reach out. I'm happy to have as many people involved as possible, especially in the international space. Everything is open and transparent. So if you want to attend a pipe sizing meeting, you're more than welcome. Anyone can attend. It's open, it's transparent, and open to anyone to be involved or just follow along. So I encourage everyone in the room to consider that and see if they want to follow that journey of pipe sizing. And that's it from me. So thank you for your attention, and thank you, Ron.
Any extra questions to Tom there? They're like the huge takeaway, like for me especially, and I know we've talked about it for years, it was we always waited till the drafts came out before we made comments or even suggestions. And yeah, that take home is put your comments in there now. If you want to make change, once it goes to draft, it's too late. So yeah,
What are the chances Australian standards will ever become free access?
Be careful what you wish for. It's my answer to that one. I'm going to have a really unpopular opinion on this. So if there was a drive for standards to become free, nothing's free. So government would have to pay for it. And if you follow the NCC pathways, the NCC is not freely available to government. That changed because government increased their funding to the agency to cover the cost of that. So they didn't have to recover it through sales. Standards Australia don't have that model. So they would have to work out how many licensed companies and sites, industry stakeholders would need access to the standard. They would charge the federal government that amount. And it would put industry in a very awkward position, I believe, because at the moment there's a very fair, open, transparent model. If government is paying the bill to develop standards and make them freely available to industry, and industry wanted to make change, if government didn't, they're footing the bill. So I think it does introduce some challenges that is not currently faced by the industry. And I'm sure Standards Australia can overcome that, but the model isn't as good as it sounds on paper. Access to the standard is under $50 a year, and you get every plumbing standard as a bundle of that on the phone. So I don't think the cost of standards is a barrier to compliance. There's no real excuse for anyone in the industry to not have access to the standard when it's under $50. I thought someone might. Yes, thank you.
NCC references 200 standards as the primary standards. People talk about more secondary standards, it's 4,000. Building means pay for that?
That is a good question, and numbers that I think I've used politically necessarily. So how many of those reference documents does a plumber need?
All right, examples, part 3. How many primary standards, or sorry, secondary standards that reference the front of that standard?
There is, I would say,
About 50,
I'd say less, 10 to 20 off the top of my head.
2 pages on it.
No, they're not mandatory referenced. So plumbing's somewhat different to building. So in plumbing, there was a process where a full review of the document occurred, and anything that was not an installation or design standard was moved to an informative reference. So it's guidance only. So it might be referencing the standard that a pressure reducing valve is manufactured and certified to. That's of no interest to a plumber or designer. But it's referenced in there.
For
Like,
example, there's not your unstable ground. It's informative or what's required. Yet the slab building code requires us to put it in. So that code only refers to part 2 sewer. Yet we get relying on an engineer to tell us they're putting it in stormwater, and it's adding another 3 to 4 grand per job. That's
Up to 8 on something.
yeah, like yeah, like
so that's a
someone's
whole
really
other
looking at it.
problem. I'll try and solve that one too. But if you look from a plumbing perspective, under your plumbing license, you're responsible for a certain types of work. Under that type of work, 3500 is the primary document referred to under the plumbing code. Then there might be the installation of PVC pipe has its own installation standard. So there might be a secondary reference also to that. Additionally, plumbers use 5601 for gas or construction and bushfire prone areas as well as plumbing requirements in it. So there are other documents outside of 3500 plumbers need access to. Most of them are in the plumbing bundle for that $50 mark. So you do get most of them, but does a plumber really need access to the slabs and footing standard or timber framing standard or brick laying standard? Probably not. So when you look at the numbers holistically across the NCC, it's not every trade that needs everything. If you're a bricklayer, you might need one standard. If you're a carpenter, you might need 10 and 20. If you're a plumber, you might need 10 and 20 as well. You don't need the full 4,000 standards across the portfolio to do your job compliantly. For the unstable soils one, that the way that it is referenced in the standard is informative as one of the options to deal with unstable grounds in the standard. That's intentional. It's normative in the building code because it is a building requirement. That standard was written for slabs and footings to make sure the building stands up no matter what the ground conditions are. There's no evidence that I've seen of plumbing failures causing issues. There's a building failure of the slab and footing movement is a reactive or unstable soils that is then subsequently broken the plumbing. So if you made plumbing in unstable soils a mandatory requirement or a mandatory consideration, it brings that onus from the building certifier, the responsibilities from a building certifier and the geotechnical engineer over to a plumbing contractor. So if you, for example, had that informative appendix in the standards mandatory, that brings on responsibilities for the plumber to sign off on that job saying, I have followed 3500, the plumbing system is going to be compliant in the reactive side of the place, H or whatever it is. So it is
being informative, but now have to go in the performance world.
it's strategically in the performance world. Yes, that's the purpose, yes. So because you need a geotechnical engineer or someone that's got qualifications in dealing with activity at the site to come up with an appropriate solution.
Yeah. The problem is there is that the geotechs won't sign off on it. And it's been, the onus is put back on the engineers. Absolutely.
But would you like to sign off on it as a non-geotechnical qualified engineer?
Has it been a problem in the past?
So as soon as you sign off saying this is complying with this whole classification, it's going to hold up, you're taking on that responsibility.
That's the problem I have.
So I would say tell them the relevance of the building certified, taking the responsibility of starting off the building and having geotechnology. And that's why it's a performance pathway, because you can't embed geotechnical engineering advice into a team satisfied pathway. It's not the best solution, it's clunky, I get it. But the alternative is plumbers taking responsibility for geotechnical designers as well. That's what we, I think, as an industry, would like to avoid. Leave it with the people that have got years of qualifications and training in that particular area. But as usual, I've got unpopular opinions.
We could have a whole night on it, to be honest. Yeah, we could definitely have you down for another session on that. Yeah.
We've got solutions in place as well.
Yeah.
Being international.
Thank you.
Just for problems.
In regards to reactive sites, yes, I think there's a pretty high housing demand everywhere in the world, which is leading most countries to build on sites that we would probably normally consider not suitable. The other side of that is resilience. So with the extreme climate events that we're expecting to increase, but we also need more housing. How do you balance that between building in somewhere like an area that you know is more flood prone, but we need that site for more housing? So how do you do that? It's kind of another comparison. Find that balance is always important. You might have a site that's field ground or light subsidence area, whatever it is, but we need to build more houses, so we need to find solutions to those challenges.
Thanks, Tom.
I'll be around later.
Yep.
And money later.
Thanks, Tom. All right, we're going to smash through it. Trivia, we got Matt coming up, and we got Anthony. We got a quick little. We got some prizes to get out, and then we'll finish up. But thanks again. And while we're going, you've still got the hot topics to fill out, or the QR codes. Just give it that.
Thanks, Ryan. Okay, we'll just knock this one out. We've got the last round. We'll just get the questions to round 2. So, which building in Greater Hobart? Better get that right now. There might be some controversy here because I did learn this building has a poo machine in it, or it used to have anyway. So on display was a poo machine, but that wasn't counted in one of the toilets that was in this facilities. So what building am I talking about? Anyone know? Yeah, there you go. You got Mona. Did the Rusty Nuts get that?
Yeah.
You got that? Okay, you're probably in the lead now. Okay, so Ozzy Osbourne, Michael Caine, and another actor, Bob Hopkins, had what in common? Anyone want to have a crack at that one? Plumbing, yeah. Any more detail, or did anyone else have anything to do with plumbing, or no? Only the Rusty Nuts? Well, they all had short careers in plumbing and plumbing apprentices or assistants, and ironically, Bob Hopkins went on and played Mario in the 1993 film Super Mario Brothers. So there you go. One of you kind of is up on that one. And the plumbing question, the presenter's question was, did anyone remember where the factory was? Yeah. Okay. Well done. Someone was listening. So anyone else get that? No? Geez. Have we got anyone like at 4 points so far out of all the questions? Anyone 4 or above? Yep. No? 3? We got mainly 3s, 2s, 3s and 2s. Okay, so everyone's still in it, I'd imagine. So here's round 3. Round 3. Well, actually, before round 3, do you remember how many mils were in that that bottle? Okay. Does anyone want to tell me how many litres in a fairly water efficient toilet system is? Full flush?
6.
It's 4.5, right? So raise of a hand. He's going to have to be pretty quick here. Raise of a hand. How many of those long necks would it take to fill a 4.5 litre cistern?
5. You can tell me you want to drink us, mate.
6. Yeah, okay, here we go. Right, another box of chocolates down here. So, okay, we're moving into round 3 now. That was a bit of a hard one at this time of night, I guess, but everyone was pretty close. So that was 750 mils into 4.5 litres, if anyone's still trying to work that one out there. Okay, question 1, round 3. Which car, so you're just back to your pens now, you don't need to yell anything out, so I'm just going to rip through 3 questions, and then I'm actually going to give the answers, and we're going to hopefully have an answer to the winner of the trivia. So, which car went on sale in Australia on the 17th of April 2025 this year? Well, someone just yelled it out, that's great. Moving right along. Someone's helping out. So, which car went on sale in Australia on the 17th of April 2025? Now, deliveries did start later in the year, but that's when it went on sale, this particular car. Question 2, what is the height of the dam wall at Lake Gordon here in Tasmania? In case there's another Lake Gordon somewhere. And that will obviously be the closest number to that dam wall height. And if everyone would like to open up that envelope on their table, hopefully you've all got one. If you don't, there's a spare envelope down the front here. What I'm asking you about that particular image in that envelope is, what is that? What is that you're looking at? You don't have one? Okay. If you don't have one, next table would lend you one, because it doesn't really matter that, oh, hang on, we got one. They're asking for the name of that image. And if you're on a table with absolutely no one that's got any idea, it's not a hammer. And there is a 4th question for this particular round, and that is from Lawrence's Lawrence's presentation. He asked, are PRV systems complex or complicated? That was Lawrence Mazoon came up with that. He kind of did say it a few times. I think he knew that you're all under the pump. Are PRV systems complex or complicated? Okay, we're going to rip straight in here now. The answers for round 3, round 3. I think I heard it a few times in the crowd. Everyone want to know what that is? Which car was it? Yeah, the Tasman. Okay, so closest to the pin here, the dam wall height. Would anyone happen to know that? Did anyone work on it? When was it built? Like, is everyone still alive? Or was it a fair while ago? Was it in the 20s? Is anyone in the... Oh, yeah, you were working on it? Oh, okay.
145.
Okay. On the answer sheet. Okay, so what do we have out there? Did anyone have? Did someone seriously have 140 something? Yeah? Okay, well, you're all right. It's 140, yeah. So well done, you know, like, well done for knowing your sort of dam heights in Tasmania. I think that's a really good thing to know along the way. And, okay, so name that tool. Did anyone have hammer? No? Soldering iron? Yep. Anyone not have soldering iron? I'm interested in something else that it might look like, but okay, it is a soldering iron. And Lawrence's question. Anyone got that one? Yeah, complex. Okay, well done. Now I need to quickly find out who is higher than 5. Yep. Okay, that's going to be a problem. Higher than 6. Higher than 6. You're 6. You're 7. You guys. What are you? You're 9. Serious? You might have to hand that up. You have to have a review. Are the Rusty Nuts seriously the winners? Did you get 9? Okay, Rusty Nuts, can you quickly come down here and just grab, we just want to line you up on the wall and hit you with the hammer. Yeah, the whole lot of you, please, all the Rusty Nuts. Just get a quick photo. Rusty Nuts, all please go over there and have a look at that. You're entitled to 1 prize each. Grab a prize each, get a quick photo, and then and that's it. Okay, thanks everyone. Hope you enjoyed tonight. Sometimes it sort of livens up the room a little bit and gets you talking to someone on the other side of the table that you might not have necessarily spoken to. Yep, so they're going to be grabbing one each. We do have the lucky door prize yet, and
Actually, still got one more run. We've still got Anthony Master Plumbers coming up. So we're not gone yet.
we've got one over here. Okay, we've got heaps to go.
All right. Okay, thank you. Okay, guys, everyone. Okay, last topic, we got Master Plumbers President's presentation to close us out. Anthony Ballick's coming down. And we do still have some lucky little prizes and everything, thanks to all the affiliates that have come tonight, and we've still got more to come, and I'll still speak again.
All right, thank you all. Just a bit mindful of time this evening, so I'll try and punch on as quick as I can. Good afternoon, HCAA members, and thank you, Ryan, for the kind invitation. It's been another busy and productive year at Master Plumbers Association of Tasmania, the state's leading industry representing employers and plumbing contractors. Over the last 12 months, MPA has continued to work closely with key bodies, including TAFE, CBOS, and more recently, the Plumbing Surveyors Association of Tasmania, to address challenges facing our trade and strengthen our industry into the future. Our membership has grown again this year, which is encouraging given the current climate. This growth allows us to provide greater support and advocacy services to our members across the state. If you're the owner of a plumbing firm or business or represent one here tonight and you would like to learn more about the benefits Master Plumber membership offers, please come and see me at the end of the evening. I'll grab your details and we can get a members pack out to you. I'd also like to officially welcome Natalie Kingston to the Master Plumbers family. Many of you may have already met Natalie at various industry events. Natalie's industry liaison officer working on the High Vis Army project. For those of you may not be familiar with the High Vis Army project, it's a Tasmanian government workforce initiative delivering in partnership with MPAT, MECA and Master Builders Tasmania. Its purpose is to train and attract skilled tradespeople, particularly in plumbing and electrical, to help meet the needs of Tasmania's growing construction and infrastructure needs. Another key part of Natalie's role is to strengthen the link between TAFE industry and Master Plumbers, ensuring our training programs, including Cert 2, are delivering the right skills and outcome for industry. Natalie also represents both industry and Master Plumbers on Education Subcommittee, helping guide training quality and future pathways. One of our current grant projects focuses on sourcing industry experts for the Plumbing Industry Expert Program. This initiative allows industry experts and subject matter experts to mentor and engage with the next generation of plumbers, ensuring apprentices and trainees are work ready, industry connected and confident in their trade. If you'd like to be involved in this program or know someone who would, please reach out to Natalie. We're chasing industry experts for that. As I like to remind people, the act of teaching is the act of learning twice. Sharing knowledge strengthens both minds. In October, Master Plumbers had the pleasure of meeting with the Plumbing Surveyors of Tasmania in Maina. It was great to finally connect in person and have open, constructive discussions about the challenges we all face within our industry. The key outcome of this meeting was a decision to form a working group made up of representatives from industry, peak bodies, including the HCAA. This group will meet quarterly and keep communication lines open, collaborating on shared goals, driving positive change within Tasmania's plumbing and hydraulic services sector. This is a very positive step forward and something we've been working hard for quite some time. By maintaining open dialogue and working together, we can present a united front, making genuine progress for our trade. Some of the other advocacy projects we're currently working on involve Keystone funding, where we've submitted expression of interest for members to sit on the Keystone board. This will ensure our industry is appropriately represented and that our members and industry have a voice in matters relating to the training funding and subsidies available to us. We're also representing the plumbing industry in the collaboration with CBOS at the moment and gas standards on a project for updating the old gas fitting notice system. That system looks like it may transition into an app-based platform, streamlining submissions for practices, and consultations just started with industry stakeholders, and CBOS is expected to call for tenders on that project later on next year. We're anticipating having more to report on that project in the coming months. I'd also like to thank Michael Overeem. He represents Master Plumbers Tasmania at a national level and Master Plumbers Australia, giving our state a voice on the national stage. Without Michael's continued support and representation, our industry and our state wouldn't have a voice, so we wouldn't be here. Before I finish, just a quick reminder, Master Plumbers Christmas dinner will be held at the Boathouse on the 28th of November. If you'd like to attend, please register with Angela. It's always a great night and be great to see some new faces. In closing, I'd like to sincerely thank Ryan and the HCAA for their ongoing support over the last 12 months. We truly value the partnership and continue to work collaboratively together into the future. It's always a pleasure catching up with everyone this time of the year. On behalf of the Master Plumbers Association, I wish you all happy and safe Christmas. Thank you.
Anthony, anyone have anything to throw out to Anthony from Master Plumbers? Well, I just want to say thank you very much, Anthony, Angela, Natalie. Tonight was actually sponsored by the Master Plumbers, so in collaboration, and that's how we're keeping everything going. So I think everyone, a round of applause to Angela and Natalie and Anthony. Thank you very much. Thank you. We're coming to the end, guys. Matt Lloyd, we've got one last round. I hope we're throwing out some lucky door prizes right now. So we're coming. We're right there. Also, just wanted to say, end of year. Thank you very much. And we got Andy and Steve that was taking everyone's attendance. Make sure you've signed in. 8? Oh, okay. Well, yeah, excellent. We've moved in. We'll say thanks for Matt for doing trivia. That was a bit of fun, bit of difference, everything there. And now we've got some special guests. We've got Gav and Shane and Steve and Andy for helping us all out. So maybe we've got a few things to give away to kick you out the door. So that would be great. And whoever's interested, we are going on to Salamanca after this. So you're all welcome to keep going.
First draw gets.
Yeah, first draw gets you get to pick.
Get to choose, yeah.
Okay, everyone got their little lucky door prize numbers. Hope so.
What's wrong?
E92 first. Yeah. We've got a few. Everyone's going to have a run to the end. E90. Yep. Good call. You get the first one. There you go. Other one. E77. No, you missed. Oh, yeah, you get another one too. Yeah, there you go. Put it on. E84. That's an orange one, anyway. What do we got? We still got an E80 orange. Oh, what Matt? Everyone's coming up. What happened here? Everyone. What the fuck? Yeah, okay, you get one too. What the fuck's E79. Is that the people on the chair as well, or is that just the bad name? Okay, we got one more. It looks like. Quick. Last one, E86. Bridge. All right, that's it.
Oh.
Can we just say thank you to all the affiliates, everyone that donated, Shane, Grease, everyone, Steve, Andy. Thank you very much. Thanks, guys. It's been really good. Thank you again. And we're done. So we'll be back in March, August, November next year. We'll get some good topics happening. Hope you all had good fun. The year's almost done. Keep up the good work. We'll keep presenters, if you want to get involved, keep reaching out. I know there's a list and a roll call, so it's happening. All heading down to Salamanca after this. Woohoo! Catch up at the Whaler, probably. Drive safe. Merry Christmas. And thank you everyone online. Try to get the criminals on there. Get a snippet. Yes, on the Are you coming or going? I think we got it. We almost got there. That's good.